blocks have been split in half on the starting line and things like that. And look, we may as well talk about it. It doesn't matter what wastegate you're using. The first rule of boost control is always have a boost cut.
100%.
And look, I understand you break an engine, you want to blame somebody, but you don't break a block in half when you've got boost cut set to anything. So
welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we're joined by Matt Wright from Turbosmart in Australia. And Matt is probably actually one of the first industry professionals that I bumped into and became friends with back right at the start of HPA's journey. At the time, Matt was actually working for Haltech Australia, but he was actually instrumental in setting up and expanding their operation in the US. After that, he moved back to Australia and we continued to keep in touch. And of course, we bump into him just about every year when we head over to World Time Attack Challenge. Matt is positioned with a really unique understanding of the industry, given the amount of time that he has spent with Haltech, and now just recently, he kind of shifted across the road and is working for Turbosmart, essentially two of Australia's premier brands in the performance aftermarket world of tuning. In this interview, we dive deep into Matt's background. We also dive into his time at Haltech, where he was there for around about 20 years. Interestingly, his start at Haltech was kind of a fake it until you make it deal, which is not uncommon in this industry, where you really only need to know just a little bit more than the person that you're providing tech support for. Of course, Matt's skills and knowledge have rapidly escalated from that point in time. He's got a unique take on the EFI tuning industry, features, functions, and how these need to be delivered to the customer in a way that makes sense and allows them to actually tune the engine, rather than not necessarily being just technically perfectly correct from an engineering standpoint. In the world of turbocharging and turbocharger support products, Turbosmart is internationally renowned and have won awards at SEMA for just about as many years as we've been going. Matt provides us with some really interesting insight into Turbosmart's background, the products that they're developing, how they continually manage to iterate what on face value may seem like a relatively simple product. We talk about their electronic wastegates, their relatively new StraightGate, which is a very unique take on boost control, and of course their recent foray into turbochargers themselves, which kind of closes the loop full circle on the products that they offer for that particular market. Before we jump into our chat, for those who are new to the Tuned In podcast, High Performance Academy is an online training school. We specialize in teaching people how to build performance engines, how to tune EFI, how to construct wiring harnesses. We also cover topics on fabrication, 3D modeling and CAD, race driver education, and data logging, just to name a few. You can find all of our courses at hpacademy.com/courses. All of these courses are delivered in high-definition video modules that you can watch from anywhere in the world, provided you've got an internet connection. This means you can learn from the comfort of your own place and you can learn at your own pace. All of our courses also come with a 60-day, no questions asked, money-back guarantee. So if you purchase them for any reason at all, decide it wasn't quite what you expected, no problem, let us know. We'll give you a full refund. And for podcast listeners, you can also use the coupon code podcast75. That will get you $75 off the purchase of your very first HPA course. We'll put the coupon code in the show notes to make it nice and easy for you to find. Lastly, if you like free stuff, then I've got a great deal for you. We are constantly partnering with some of the biggest names in the aftermarket performance industry to give away some great prizes. You can always find our latest prize at hpacademy.com/giveaway. It might be an aftermarket ECU or dash. It could be some engine components or engine building tools, or just about anything in between. They are great prizes and we will ship them free of charge to your door if you're the winner. There's no tricks here, no purchase required to get your name into the draw. All right, enough with our introduction. Let's get into our interview now. All right, welcome to the podcast, Matt. Thanks for joining us. And as always, let's start by finding out a little bit about your background, specifically, how'd you get an interest in cars?
Well, thanks for having me to start with. I guess I've probably always been interested in cars. My interest in working on cars, though, I didn't come from a background. I wasn't like I've got a dad or an uncle or something that owns a shop like a lot of guys tend to have that. It was more a matter of, I think my dad's a bit of a tight ass, and so rather than taking a vehicle to the repair shop, he'd give it a crack in the backyard. And so we always had pretty much shit boxes growing up, but they were always breaking down because they were shit boxes. That's sort of life, right? And so I had a bit of an exposure to a willingness to, hey, give something a go. So when I was, I think it was like 15, so before I had my license, I had my first car, and it was a bit of a shitbox. And the local mechanic that when Dad got in over his head, we'd take the car to, he was a sort of family friend as well. And it was a 1963 Mini, so tiny little piece of motoring history. But you take one of those into a workshop with a mechanic that's got bear-sized hands, and they look at it and go, yeah, no, I'm not touching that. So he more or less said, I'm more than willing to help you out with this car, but I can't fit my hands in there, so I'll tell you what to do, and you can do it. And so that sort of started an apprenticeship of sorts at the local mechanic, because the thing was broken down all the time. And so I was there quite regularly as a 15, 16-year-old. And eventually it turned more into, I'd be walking home from school and he'd see me walking past the mechanical shop and he'd be like, can you just give me a hand this afternoon? The place was always busy. There were 10,000 cars there all the time. And it was just a regular workshop, doing registration checks, brakes, clutches,
So not a performance workshop?
No, not at all. Yeah, had a bit of an apprenticeship there with the local mechanic, and that continued on. So I finished school, still had my shitbox. I finished school. That really probably, I didn't know what to do, and I left school. I did relatively well academically, so I had the marks to go to university. But look, in Australia, to get into university, it's a fairly simple ranking system. So back in the day, it was you got to score. You do your leaving exams, HSC we'd call it, and you basically got a ranking, 0 to 100 based on the marks in all your subjects. And depending on where that ranking's at, you got a mark of 99.95 or something, you can do medicine or law, and you sort of go down the rankings to different degrees you can get in. It's not like, say, America, where you've got different universities that specialize in different things, and you have a big interview process, and you have to write your life story, and you've also got sort of, these are the things I've done within the community. It's purely a ranking-based system. So I did well enough to get into engineering. Actually, before that, I was looking through, there's a guide. They called it the University Admissions Guide. It's basically a telephone book of all the courses that every university offers and the ranking you need to get in. I'm in last year of school looking at that, thinking, I'm reading through all the degrees, all the possibilities. It's like law, look at that, look, that's boring. Vet science, actually doesn't really appeal to me. And I promise you, I went through this telephone-sized book of university degrees, and the only thing that was even remotely interesting to me was mechanical engineering. So
I get that.
Let's put that down. So that's sort of went hand in hand with what I was enjoying doing. I sort of was working at the workshop on pretty much every afternoon and weekend at this point. And so,
but you obviously had decided at this point you didn't want to pursue a career spinning spanners for a living.
Yeah, and in hindsight, I think that was probably a mistake. You go to university for 4 years, you come out, you got a degree and basically zero experience in anything. And I don't know that I'll encourage my own children to do the same thing. I think there are 25 years of work experience under my belt now. I don't necessarily see the value in a degree education. I don't think it's a requirement for success.
We've talked about this with numerous guests on the podcast, so at the risk of kind of running over the same material our listeners have probably heard, I absolutely agree wholeheartedly with what you've just said. I went through a 4-year degree and a Bachelor of Technology, graduated with honours. My major was product development, and I used not a single element of that degree. However, what I would say in a subtle aspect of this that has benefited me with what I do is in my final year, we had to do an impromptu off-the-cuff presentation to a class of, I don't know, like 100 people or whatever it might have been. And we did that once a week. And at the end of that year, I have zero problem talking publicly. It just doesn't bother me, where I know that's a big shortcoming for a lot of people. They're terrified of it. And obviously with what I do with presenting course material, that has played into what I do. But was it worth 4 years of my life? I don't know. The other point is we had Dimitri from BBI Autosport on the podcast, who is now developing some of the most advanced cool products that you could imagine. And he's doing all of that without a mechanical engineering degree. And, like you're saying there, his benefit as he sees it is he's got the runs on the board, the hands-on experience rather than 4 years of theoretical experience. And you can go back. I mean, there's books, there's courses, there's resources to learn those skills that you need as and when you need them. So, yeah, I agree, and I have the same policy with my children. Hey, if they've got an absolute passion to go to university, or of course, if you want to become a doctor, lawyer, architect, well, hey, you got no option. That's the path you're going down. But if they don't want to do that, I'm definitely not going to strong arm them to go to university.
What I will say is that one thing I believe that university did do is does teach you how to learn. On the one hand, is the knowledge that I acquired at university useful on a day-to-day basis? I don't think so. I think very little of which is great background knowledge. It does allow me the background knowledge to look at a problem from a certain perspective. But it really does equip you to be able to learn, to be able to say, okay, this is the problem. How do I look at it objectively? And how can I minimize the number of iterations? Because there is the, break it till you make it mentality. And I think that a lot of people end up being very successful by that. They just make enough mistakes. They learn from those mistakes to enough times to be successful. That's very common and not a terrible way of going about things, because you do gain the reps. You get the repetitions and you learn. I think that a university degree helps you shortcut the number of mistakes can help you shortcut the number of mistakes you need to make to get to your result.
I think that's actually a good way of explaining it. And just to come back to you learn how to learn, the reality is, of course, with almost any degree, you can't learn everything that you need for a specific job. And, particularly if we're talking mechanical engineering, that industry is so vast. You could be designing a bridge or a motorsport upright, and obviously they have crossovers, but they're completely different products. So I think from an employer's standpoint, someone with a degree, I don't expect to employ them and have them hit it out of the park on the first day. But I know that they've obviously shown the ability to learn, to tick all the boxes and get that degree. So therefore, they're going to be able to learn within my business as well.
Yeah, I feel like there's a minimum level of technical competency that they have, but they've also proven a university degree, you get through your 4 years or 3 years, 4 years, 5 years, whatever it might be. You've also proven you have the ability to stick at something that is difficult. Work ethic, ultimately, that's what it comes. You're either particularly brilliant and you can get through things without putting the work in, which I do want to hire that guy. All you got to do is motivate that guy because he can probably do anything. Or the alternative is you've got the work ethic to sit down and nut something out and just stick with it. So both of those traits are super valuable. So I'm not necessarily going to push my own kids into university. I think you can be super successful without a university degree. However, if you do go ahead and get that degree, don't think that's not the end. That's not where you've arrived. That is just proving that you can do something, and you still got to then go ahead, put the reps on the board. You will be 4 years behind the guy that left school and started getting his hands dirty, but you should be able to come up on a faster trajectory because you've got a good base knowledge and you have the ability to learn and persevere.
Yep. Well, I think we're way off trajectory here, but now that we've bleated on about tertiary education, let's get back to what you did with this degree that maybe you regret actually.
Well, don't necessarily regret it, but I don't know if I do it again. So I was working at the workshop throughout those 4 years of university as well. So by the time I entered the industry, I had 6 years of experience, I think, hands-on in the industry, not performance.
At this point, I was going to say, are you actually at any point developing a passion for the motorsport side, the performance side of cars, or you're just fixing stock cars?
Not really. No, not motorsport. Performance, yes, but motorsport, not really. So that sort of comes later. From a performance perspective, that's, I guess, just the young man's growth. He starts with a shit box and he gets it working, he gets it going well. Like, what is enough? There's never enough. So, minis turn into datas get turbocharged get fuel injected turbocharged, and that's how it is. And so that's where I ended up at Haltech. Actually, I grew up 10 minutes or so from the original factory down in Tarrant Point in Sydney, and I had a Data 1600, put a CA18 into it, and a couple of guys that I know had used Haltech. I mean, there wasn't a lot of option back in the early 2000s. Haltech being the one in Sydney that was local was the obvious choice. A pretty small company back then. And so one Christmas Eve in 2000, maybe it was 99, 2000, somewhere around there, I went down and picked up an E6K and a Flying League kit.
You're giving me PTSD.
I know. And that was when it was brand new.
Yeah.
It was pretty exciting stuff, and spent my Christmas break reading through the instruction manual, poring over the very poor detail in there, figuring out how the hell do you install this thing, how do you set it up, how does this software work. We got it up and running, so that was pretty cool. I did have to go down there a couple of times for a few bits and pieces that I broke. They were igniters and coils and things that I think back in the day, a lot of people went through those when you got one setting wrong in the software and set those things on fire. Yeah, been there, done that.
Yes.
So it was a bit of a baptism of fire there. And there wasn't a lot of information. You couldn't just jump on Google and find out this stuff because the information straight up didn't exist. So it was a learning curve, but it was a good one. After I had that car running over the Christmas break, we got up and running, put a rough tune in it, which just banging the piano keys up and down to get the fuel right so the engine sort of ran. And I took it down there and it ran. And that was a win for me. At the time, Adam Nish who's just engine management, was working there in tech support. And I developed a bit of a relationship with him just from buying parts off him. And he said, "Hey man, I'm going to leave and I'm going to do my own thing. I'm going to start just engine management." And he said, "You'd be a good fit for this job if you're interested."
Right.
And I thought, okay, maybe. I guess I just finished up my degree actually, and so I was working elsewhere full time, not in the industry, and I thought, all right, I'll put my hand up. So I did. I walked in one day with a resume, which is sort of handwritten on a piece of paper, and I gave it to the owner, who at the time, the original owner had passed away, and so she was sort of caretaking the place, trying to sell it. It was a little bit of a schmozzle, but they were in need because they had no one to do tech support. They'd employed an operations manager that really knew nothing about cars. He was an electrical engineer, but he knew nothing about motor vehicles. And so I sort of started pretty much without any real, they didn't even have anyone interview me that knew anything about cars.
Am I right in sort of saying from the story you've told us, you sort of would have moved into Haltech tech support without actually too many runs on the board in terms of actually installing, tuning Haltech product?
Yep, correct. Yeah, I had a grand total of one install and setup of a Haltech ECU under my belt. That's not true. I actually probably had three because I had a couple of friends that had also had Haltechs and we worked close together. Actually, Scotty from Haltech, we've known each other since high school, so we were friends prior to Haltech, and he's sort of part of the network of guys that I used to hang around with, still do, but back when we were teenagers, young punks, he actually worked at the same workshop that I worked at on weekends, so he was into Cordia turbos, and he was always putting big boost into things and breaking things, and so he had a Haltech as well. Bo Yates was part of that crew as well, and I think he had the first of the Haltechs, Bo, who's pretty prominent in the drift scene over here, or has been over here in Australia. So there was a few of us in the area that had a bit of experience and a bit of knowledge and were willing to just get our hands dirty. We're all just punks, teenagers. It's funny how 25 years later, those of us that stayed in the industry have done pretty well out of it. So we had a little bit of experience, collective experience between us, but you also have to remember there wasn't a lot of experience in the market either.
No, this is kind of almost the birth of this aftermarket industry.
Yeah, it really was. It wasn't like HP Academy didn't exist. There was no training institutions. You couldn't learn it anywhere apart from doing it yourself. And most workshops just weren't interested in doing the learning. So you're either a race team or a workshop that was fumbling along just as much. And I think for a lot of workshops, I mean, I was 19, 20 at the time, but even as a 19, 20-year-old, I sort of grew up in an era where I had a keyboard under my fingers from early teens. Now, if you're in a workshop and you're a performance workshop, you're probably a further 10 years down your career path by the time you're owning a performance workshop. So those guys, they didn't grow up with a keyboard under their fingertips. So even though I'd only installed one ECU, and reality is the wiring side of things not that complex. What most people don't realize with an EFI system is it looks complex. You look at that wiring harness and you're like, oh my goodness, you've got hundreds of wires here. What do they all do? It's just a combination of very simple circuits. So you don't have any circuit that's more than 4 wires. 4 wires aren't complex. It's just that you've got a lot of them.
I think that the thing that puts a lot of people off in terms of wiring, and not just ECU wiring, is the whole car chassis as well, chassis wiring, is you can't see voltage, current and resistance unless you screw it up and the smoke gets out, and then it's too late anyway. So when you can't visualize these things, I think there's just like a mental block in place that people think, oh, I can't do this. But the reality is, if you understand, a sensor, let's say throttle position sensor, a map sensor, it's going to have a regulated 5-volt supply. It's going to have a sensor volt 0, and then it's going to have the analog voltage input. And that's how a sensor works, or a negative temperature coefficient thermistor for engine coolant temp or intake air temp, 2 wires, sensor grounds, and the input.
I mean, and that sounds really complex, what you just said. You just used a hell of a lot of jargon there. You got a negative temperature composite. You know what that is? It's just a resistor that changes its resistance with temperature.
Yeah, that's I did really overcomplicate that situation. Thanks for pulling me up on that one.
No, it's okay. It is what it is. And I think that's one of the areas where, going back to the degree, having a mechanical engineering degree, I mean, you do a couple of courses in electrical engineering and you only needed a rudimentary understanding of what a circuit is. So that actually didn't frighten me. I was able to handle that without an issue because, like I said, it's 2 wires and 3 wires, just lots of them. Once you get your head around that, you're like, oh, okay, this is actually not as complex as it first seems. And so the job really becomes, well, let's ensure that the connections are correct. And once you've got that, it's a matter of let's get onto the laptop and make sure you've got the settings correct so the signals are correct. And I did have a relatively reasonable understanding of what the signals needed to look like. You can do that after the first installation. Once you know, okay, 12 volts, okay, that's the signal being high, ground, that's low. This is what triggers the output to do something. Okay, you've got a fuel injector. It's got 12 volts on one side, and the other side gets a ground signal to complete the circuit to open the fuel injector. When you kind of understand fundamentally what the actuator is doing and how it operates, there's not anything that complex about the inputs and outputs of an ECU.
I guess the other thing that's worth pointing out here is around this period, sort of late 90s, early 2000s, it was simpler times, simpler cars, simpler ECUs. We didn't have continuously variable cam control, or we're probably just starting to move into it. And I know that a lot of the ECU manufacturers also lagged that VVT support for a good few years because it was complicated and probably required some hardware changes. There's no CAN bus, or at least again, the CAN bus is very, very early on. So, definitely simpler times compared to what I can imagine tech support in that role would look like today, where the ECUs are just a completely different animal. I'm guessing there's a bit of imposter syndrome going on here, a bit of a fake it until you make it.
Absolutely, yeah. You start in that tech support role. It was definitely an eye-opener, though. The thing that I was most shocked by was the number of questions that you would get were so simple. Most of the workshops actually didn't have the parts that I didn't understand, which was the tuning, and I was certainly afraid of, like, well, pushing those numbers up and down affect the amount of fuel going to that engine, and that makes heat in the combustion chamber and melts pistons if you get it wrong. So the parts that I probably feared the most, they were not where the questions are. The tuning is not where the tech support comes from. It's getting the car up and running, and that was actually an area that I felt I didn't really have too much of an issue in. Once you understand fundamentally there's not a lot to it, the biggest issue was all the different crank sensor patterns and crank sensor types. That started getting but even then, back in the day, it was much more accepted to just say, I don't know what crank sensor's on that car. You need to throw 4 magnets on the thing. So you machine up a wheel, stick it on the crank pulley, 4 magnets in the sensor, hunky-dory.
Give it something that's a known quantity to Haltech, and then you know it's going to work.
Absolutely, yeah. And that was always the backup that you could, and it was fairly well accepted in the marketplace that sometimes with EFI, that's what you got to do. Whereas that's not the case anymore.
Yeah. Without sort of blowing sort of 30 minutes on this, is there kind of like a top 5 common tech support questions that you could think of?
The most common question you'll get is, how do I get my car running? That always comes down to the crank sensor, cam sensor setup. So you've got 2 sides of that. You've got the wiring, making sure that the sensor is wired correctly, whether it be a digital sensor, reluctor sensor. So you've got to get the inputs in the right spots. The pattern of the crank and the camshaft themselves. So ensuring that the ECU that you have recognizes that crank and cam sensor pattern. They're the 2 big things. And obviously the ECU needs to have that pattern predefined, or doesn't need to, but at some point it does. Setting the base timing, so synchronizing the position of the crank and cam sensors with what the ECU thinks is top dead center. Once you get those things sorted out, it varies from that point. Obviously, injector flow rates are a big thing, especially now with pretty much all ECUs having a volumetric efficiency-based system. You've got to get that injector flow rate in the ballpark. But once you've got that sorted out, it's relatively smooth sailing. There's a big void in the question asking until you get to the more complex control strategies.
All right, so as part of your time with Haltech, and again, without sort of going too deep down this rabbit hole, I think the first time we actually bumped into you and met you was at either PRI or SEMA in the US, and at the time I think you were actually working or manning Haltech's US branch. So can you give us a bit of a insight into how that all worked and what your roles and responsibilities were there?
Yes, I'd been at head office for 2 or 3 years in sales and tech support role, and the opportunity came up to go to America. We actually had an employee that had been from Australia that had been sent there to open up a subsidiary office for Haltech in the US. We actually had a distributor there back in the past, I think 4 or 5 years prior, out of Dallas, Texas. But when the previous owner actually passed away, and they shut the US office down. They brought everything back to Australia. They sold the business, and so that's I came in after all that had happened. So we hadn't had any presence in the US for a couple of years.
I can assume it would be very hard to get traction in an overseas market if you have to ship everything out of Australia. I mean, when people want an ECU, they want it today or at the worst tomorrow.
Yep, that's exactly right, and that was the opportunity that we saw. US is obviously it's the largest performance automotive market in the world, and we had some customers there. We were doing reasonably there when we had an office, and those sales had really kind of dropped off to one or two customers, and chasing the growth, and the world was getting smaller with the internet and those sorts of things. So decided, hey, we need to get this US operation. If we really want to grow, if we really want to expand, we need to get this US sales operation off the ground. We actually did have a sales manager at the time who got sent over there. He didn't work out. He didn't know enough about the product. And so we quickly realized that actually the most important thing that the market needed in the States in particular at that point in time was someone who actually understood the product and how the application worked. It's no good selling a million products into the market if no one can use it. That was where I got the tap on the shoulder to head over there. And so I moved over, got married to my girlfriend at the time. I was worried. I said to my boss, I said, "Oh, look, I'm ready to go to America. I don't want to leave the girl." He says, "Well, just marry her." And so 8 weeks later, we got married and moved to America.
Easy solution.
So worked out. Yeah, that's it. Now we've got 3 kids. We've been together 25 years, and it's all okay. So that worked out well. But yeah, I ran the US office there for I think I lived there for 6 years in total, and it was a good experience. I've done 2 stints over there, so 3.5 the first time and 2 years the second time, or maybe it was the other way around, actually 2.5 and 3. But I spent quite a few years living and breathing the US market. Great experience. It's like a second home to me.
I just wonder if you've sort of picked up any subtle nuances and the differences between the way the US market approaches modifying cars and the way I think, at least for me, Australia and New Zealand, we have a very similar approach, and we obviously get access to very similar cars, but I've always seen quite a difference in the car cultures and how people modify cars.
Massive difference, and it comes. There's a number of inputs to that, and a number of reasons why. In Australia, and the best way to describe it, I think, is in Australia and New Zealand, your workshop can't survive specialising in one particular vehicle. It's just not the market for it. You can't just survive doing B series Hondas, for example. Maybe one workshop in Australia can do that, but you can't have one in every suburb, sort of thing. So most performance workshops in Australia sort of do a bit of everything. They'll be doing a big block Chev one day, and they're doing a front wheel drive Honda the next day, and they're doing a carburetor one day and E5 the next, and that's part and parcel. They're welding, they're fabricating, they're doing a bit more of everything. Whereas you don't need that same level of spread in the US market. The population is big enough, and the market is big enough that you just specialize in B series Hondas. You can have a very successful workshop with 10 techs working for you, and you can very much specialize in that one thing, which means your depth of knowledge in that one platform is very, very deep. So that's a real benefit. The disadvantage is your breadth of knowledge in the market can be limited. So what you may learn in a rear-wheel drive big block setup, you never get opportunity to learn that because you end up being so hyper-focused on this front-wheel drive B series stuff or whatever the case may be. So fundamentally, the workshops can operate quite differently, and the market operates differently. The other thing is you do have some of the distribution networks in the States are probably significantly different as well, in that you've got your Turn 14s and your Summit Racing and the warehouse distributors who are operationally so efficient that you can have parts same day, next day arriving from Turn 14, who has every manufacturer under the sun in stock all over the country. And so the manufacturer doesn't always form the same level of relationship with the end user and the workshop that the manufacturer might do in Australia and New Zealand, because we have to be close to the market, because that's how that's what the market is.
I'm interested actually just on that note, and again, we're getting way off topic, but this is interesting, so let's go. In terms of how a workshop operates in the US, so pretty much just to your point there, if I'm running my old shop in Wellington, New Zealand, and I've got a question about a Haltech that I've got on the dyno, I literally pick up the phone and ring Haltech in Australia. Hopefully Haltech's open. That'd be nice. Fortunately, our time zones aren't too far apart. So in the US, I've got my performance workshop and I'm buying all of my product from Turn 14, and then I've got a problem with my Haltech. Do I ring Turn 14? Because I'm just assuming that it's going to be difficult, if not impossible, for them to have a tech department that has the breadth of knowledge and depth of knowledge on every single line item they sell.
Correct. That is the challenge in the US market. And one of the reasons that Haltech has a company-owned office in the US rather than putting all their eggs in the warehouse distributor model. And we set out to do that from day one, recognizing this exact issue. It's a little bit different if you're selling a different product that bolts onto a car. There's not a lot of tech support. But in the ECU market, you definitely, for Haltech in particular, it doesn't matter who you are. If you've got a problem with the product, you call the company-owned office and you get tech support from the company.
I guess as well that from an ECU manufacturer's perspective, that really plays into your favour, because it's always the old story that if the ECU gets installed by a shop tuned poorly, they've done a setup wrong or something's wrong and basically the car's driving like a pile of dog shit, it's always the ECU that gets the blame. And then old mate with his B-Series Honda that's not running so flash tells all of his friends and everyone on the forum that the Haltech's a pile of shit, and next thing you know, your reputation's down the drain. So definitely plays into your favour to actually support the product and get the result that the ECU's capable of doing.
Yes, that's the approach that we took there, and I think it's the best approach to take. Not every manufacturer has taken that approach in the US, and I think the results probably speak for themselves. I think Haltech has grown significantly well over there, where the majority of sales of Haltech products are into the US market now. And so it's had a fantastic growth trajectory, and now being a US-owned company, Haltech changed ownership about 18 months ago from Australian to US-owned, and so it's wholly and solely now US focused, even though manufacturing still happens here and head office is still here in Australia. It's US owned and has much more of a US focus, and you see that with the current products coming out of the place. With the most recent release of the Rebel LS ECU, it's very much a US centric product. So it's a success story in my eyes.
Yeah, absolutely.
Quite proud of that. That's a company, the little Australian company that no one had ever heard of, with 9 staff when I started, and there's now multinational offices, 4 offices around the world, and the 100 staff, owned by one of the biggest performance aftermarket conglomerates in the world. That's a massive success story for Australian business, and I'm proud to have been part of that along the way through.
Yeah, absolutely, as you should be. No doubt your role played a big hand in that success. Again, without getting too far off topic here, just something that I would be interested in finding out about. I remember 20 odd years ago when I was running my workshop in New Zealand, and we had a small electronics company based in New Zealand. I won't mention the name, probably irrelevant anyway, and they were making some little sort of add-on boxes and sort of boost cut defenders and things like that. And the product worked. It was nothing particularly advanced or excessive, but I remember I knew the owner quite well, and he looked at breaking into that US market, and they were making, I don't know, like call it 1,000 sales a month between New Zealand and Australia, and they broke into that US market. I think they partnered with one of the sort of bigger ranges, I can't remember what it was, like the super cheap effectively of the US, maybe whatever that might be, and their first order was for not 1,000 a month, they wanted like 50,000, and the problem was that the company was not really that well funded, and stepping up from production of 1,000 a month to 50,000 requires a lot of financial resource. Then you got to ship the stuff in a container to the US, then it's got to be distributed, and then the company they're dealing with worked on sort of 90-day invoicing, so you're out of pocket for 3 months or more. Was this a problem for Haltech as well, sort of bridging that gap between the volume sales for the New Zealand and Australian market that you had and then stepping up to the US, or did that growth sort of happen gradually enough that you could sort of build up to it? Long-winded question there, sorry.
No, that's okay, yeah. That is a story that's not uncommon. That wasn't the case with Haltech. We didn't have that level of explosive growth, and I think that came down to the time at which we entered the market so long ago, and also the fact it's quite a complex product, and you had to really train people up on using the product. So there was much more work involved in getting those big sales. So yeah, it wasn't a matter of something you can just bolt on. So you get a supplier, and all of a sudden you've got an order for 50,000 units. That never happened. Unfortunately, fortunately, I mean, we still definitely went through the growing pains of having to produce more product and having to deliver significantly higher volumes, but we had the lead time to do it.
On that note as well with production, and this is an area, at least as far as I'm aware, sets Haltech apart in that you have your own in-house production for all of the electronic circuit boards. I think most of the ECU manufacturers outsource this. Advantage, I guess, as I see it, gives you a lot more control over the lead times of your products. But, was this production line sized appropriately for the growth into that US market, or was this sort of a case of, we now need to triple what we've got in-house to cope?
Well, 6 of one, half dozen of the other. So we were already in the US market when we set up that production line, and it basically came down to economics. We looked at how much we were paying our external contractor here in Sydney to manufacture printed circuit boards, or actually, well, put them together anyway, put all the pieces on the board and solder all the components on. And there's a basically a relatively linear tipping point to say, well, once you get past X amount of units per year, it's just more cost effective to buy a machine and an employee and run it in house. And that happened relatively quickly. And fortunately for us, the technician who was operating the machine at the manufacturer that we were having make the boards for us, he was a good friend of one of the guys that we worked for us. And so we bought both the machine and the employee from that subcontractor.
Package deal.
Package deal. Well, I mean, they didn't appreciate that being a package deal. It was nice for us.
I'm sure they didn't.
But that came on board, and so that was a massive step forward in the company's trajectory, because, like you said, you do have much more control over your supply chain. So there's a lot to it. It probably, I mean, it was a great thing. It added complexity. It costs more than you expect because now you've got to control more components. So it's not just a matter of a machine and a guy to run it, but you've got to have all the components in stock, and you've got to stock those components in reels. Everything comes in 1,000, 2,000, 10,000 reels. And so you're probably sitting on more inventory. But the other advantage of that is because Haltech also not just manufactured all their own components in-house, but you design them in-house, you also know what components you've got in-house to design with. And so with electronics, there's more than one way to skin a cat. You might have 10 million 1K resistors, but you need a 2K resistor in a circuit, or you can just bang two 1Ks in a line. And because you've got those components in stock, you can turn around prototypes really quickly. You don't have to be sitting on inventory of two different parts where you might end up using maybe not the most part effective, but when you're only making 1,000, 2,000, 3,000 products a year, that can actually save you significantly in other areas, time to market, inventory costs, those sorts of things, turns ratios. So that was the real advantage in having that manufacturing in-house. It's just bringing the design phase closer to the manufacturing phase. It probably didn't really pay significant dividends until COVID.
I was gonna ask about COVID because obviously there was a lot of chip shortages. And I know a couple of the other ECU companies, or just even electronic parts manufacturers for the aftermarket, they were sort of forced to switch to chips or electronic components that they actually could source.
Yep, correct. And so that was an area where having all the manufacturing in-house, you can pivot very, very quickly. You can react quickly. And so, like everybody else, Haltech went through the chip shortage, and there is, I think at the height of COVID, the engineering guys were punching out 5 or 6 different PCB designs for each ECU based on orders that we had, not knowing what was going to show up component-wise. And so you're just like, okay, because there's a lead time on everything. You design the printed circuit board, so there'd be the tens of thousands of printed circuit boards without components on them that ended up getting scrapped because whatever components showed up. So we loaded those ones, and you could make ECUs. Most of that stuff doesn't make a big difference, but it could just be a different footprint on a component. Operationally, they work exactly the same, but you have to it's a different footprint, like it's a different sized component. So you literally have to have a new printed circuit board to put that piece on. So having the ability to manufacture things in-house in a situation like that really gave Haltech, I think, a leg up in the competitive landscape. It was an absolute nightmare at the time. Logistically, it was...
Oh, no doubt.
Oh, so frustrating. But if you look at, I think, the trajectory of the company and versus everyone else in the market, I think the company fared pretty well through that.
I won't mention names, but I am aware of at least one company that for a very long period of time just couldn't ship product.
Just could not produce an ECU or a dash. Yes.
Yeah, it's hard to A, make money when you can't ship product, and B, of course, when people can't get your product, that makes them look at alternatives, and maybe they don't come back to you once the alternative.
And that's a relationship, and that's an opportunity that an entrepreneurial sales manager takes advantage of, right?
Got to do what you got to do. All right, moving on. The industry obviously has changed so dramatically. Is there any single aspect of the aftermarket ECU development that you've sort of seen over your time, from the early days to when you left Haltech, that's been like the key pivotal moment or pivotal technology you've seen come in?
I think from a market perspective, volumetric efficiency tuning being the norm. When I started, it was all injection millisecond timing. And the second thing is the introduction of affordable wideband O2 controllers.
Oh, absolutely. Yeah.
I mean, when I first started, you couldn't buy, I think M&W was the only person that sold a semi-portable wideband. And it was $1,600 and it came in a big black Pelican case and you took it from vehicle to vehicle. Yeah, you're laughing because you know the one that I'm talking about.
Absolutely do. Yeah.
I think Innovate in the States pioneered the low-cost wideband. They came out in whatever year it was, 2004 or 5 or something. You could buy a wideband for $400, and it was like, whoa. And obviously they've come down since then, and now they're integrated into ECUs, aftermarket ECUs. That affordable wideband has changed the game, and like I said, the natural progression going to VE tuning, I think, was just more of a natural progression, but it just makes the tuning process so much simpler. You put in a few extra parameters, mainly injector flow rate, and all of a sudden every base map can start and run and look the same, and you've got a closed loop O2 controller on there with a wideband, and you don't actually need to be a genius to get any car up and running. Once you've got the base timing right and the injector flow rate right, I mean, if it doesn't start and run, you're doing something seriously wrong.
Yeah. I'd sort of actually take a different angle to that. I saw sort of when the advent of VE modeled fuel table sort of came out, and it became kind of like almost a big marketing ploy as I saw it, and you kind of saw all of the ECU manufacturers jump on board. And to me, don't get me wrong, it's got advantages, and I see some of the advantages more in so much as if you've got your injectors characterized correctly and you've got your VE table dialed in, and you get to a point where, hey, I've upgraded the turbo and now I'm out of fuel. I need to swap to a bigger set of injectors. For all intents and purposes, switch injectors, change the characterization data for those injectors, and your VE table should not need to change because obviously the airflow into the engine hasn't changed just as a result of changing injectors. So it simplifies, in the old days with injection time-based tuning, we'd probably have to touch up quite a large portion of the map to get it back to being correct. Unbelievable when you start looking at flex fuel, because again, obviously the VE of the engine doesn't appreciably change as our ethanol content changes. Caveat before someone pulls me up. Yes, I know that there can be some subtle changes. Don't sort of get too fussy about this right now. But I mean, it does massively simplify that. But I mean, I know Haltech incorporated injection time literally as it was. You had the millisecond in the cell. Other ECUs that I was tuning at the time, the old Goldbox Motec, or even
your IJPU number, which is just a multiplier of that value.
Yeah. So then you sort of had still a table that for all intents and purposes, 0 to 100%. That kind of almost replicates a VE table.
Put a map correction on that, you're getting fairly close, and if you get your IJPU multiplier right, then you're almost bang on a VE table. Yeah, I get it.
Yeah, so I kind of I didn't see that coming from that style of ECU with a main injector pulse width and then the map correction in the background and your table of 0 to 100%. I didn't see it being a massive game changer moving to VE.
Yeah, that's okay. That's your experience as a workshop owner, and without wanting to blow too much smoke up your ass, you're probably one of the more switched on workshops. From a tech support perspective, from an ECU manufacturer, not everybody comes to this with the same level of understanding of how an engine works. That's the reality of it. And certainly even outside the workshop space, the end user space, that was a game changer. And your particular knowledge might make you a little bit of an outlier in this. And likewise, I have no problem with injection milliseconds and Goldbox Motecs with the IJPU numbers. It's fine. You can do everything you need to do with those problems, but with those ECUs, it's just for the average guy or the guy that's not spent a lot of time tuning an engine before. VE tables just make life simple to get things up and running.
Yeah, that's an absolutely valid point. And to the point where in our worked examples using VE-based tuning, I'll literally go through, all right, cool, we've got our injector parameters all dialed in. Here's what we're going to do. We're just going to set the entire VE table to a value of 50%. Chances are the engine's going to start and run. Probably might be rich, might be a little lean, it's going to run. And then we can start dialing it in from there. Whereas you're absolutely right. If it's injection time, I mean, most people new to tuning don't know if the engine's going to want to idle with, 1.5 millisecond pulse width or 7 milliseconds. They don't have the runs on the board. And of course, that's going to depend on your engine and your injector size as well. So it is more complicated for sure.
And then trying to explain the fact that, actually most engines are probably going to idle with an injection millisecond time of, 1 to 2.5 milliseconds. Doesn't matter what the size of the injector is. But at full noise, that could be 4 milliseconds, it could be 14 milliseconds. That's where all the difference is.
Yeah, true.
Because you've got the dead time, which may or may not be incorporated into that injection millisecond map. You can turn that on. It's just not called injection millisecond map. It's called battery correction or whatever. And so it just rolled up a lot of tuning idiosyncrasies into, when you move to VE style tuning, then the parameters you need to put in is super important. You need to know an engine capacity. Cool, great, no problem, I'll put that in. You need to know the injector flow rate. Oh yeah, that makes perfect sense. Injector dead time is pretty important. So, find that out and bang that in. And it's easy to explain. This is a whole new model. The ECUs modeling how much air is going into the engine, so it can calculate how much fuel to put in the engine based on these parameters. That's going to be, flow rate, target air fuel ratio. And so because you had that more information going into the system, it was actually easier to explain to people. All right, you do these 6 steps, 7 steps, whatever it might be, and fundamentally, internal combustion engine, 4-stroke cycle, they idle at 45 to 55 volumetric efficiency, and they're going to max out somewhere near the 95 to 105 range.
I think one of the things I also saw as an early challenge with those moving across to VE-based tuning is the workflow is different. You've already highlighted, we've got some base parameters that are absolutely essential, garbage in, garbage out. If we don't get these right, the whole thing's going to be a shit show. But at the same time, the bit that people missed was we also need to set our base air fuel ratio target table at the air fuel ratios we want to achieve. And if you haven't come from that VE, often I'd see people would leave that table at whatever the default values were, which is probably going to be wrong, and then they're fudging the VE table in order to get the actual air fuel ratio they want, sort of hence defeating a lot of the purpose of VE tuning.
Yeah, alternatively, they've come from a flash tuning world where they then have a table in the VE map and they're adjusting the target air fuel ratio map to vary the actual air fuel ratio. I'm like, no, you're doing it the wrong way around. No, you need to get the VE map to match the target AFR map, not the other way around. That was super common in the day as well. And then they turn on closed loop control, like it's all over the place. I'm like, of course it is. You've changed the target, man.
Yeah. I think it's just that level of kind of the learning curve is obviously steep with anything that you get into that's brand new. But if once you actually understand it, it sort of all makes a lot more sense. Last question on the Haltech journey. What would be the feature that you would like to see added into the Haltech range, or for that matter, any aftermarket ECU range? What do you think's missing if you had your choice and looked into your crystal ball?
I actually don't think it's missing, yeah. The one feature that I don't think is actually missing in the Haltech or Motec or a lot of the more competent ECUs, but it's just not used, is VE map having map over exhaust map as the load axis. I think that's a very genuine representation of the drivers of the engine's volumetric efficiency. So it's not commonly used as a load axis, but if that were commonplace, it would greatly simplify, perhaps not greatly simplify, it would greatly simplify the tuning process, but it would also amazingly increase consistency.
Well, I think it's the only way, and I'm really just quoting from Andy Wyatt, who's now, I think, head of development at Haltech X at Attronic, one of the smartest guys I think I've sort of bumped into in the tuning world. But it's the only true way of properly accounting for changes in barometric air pressure. And obviously we're going to get these at sea level anyway, day to day, but also the best way of accounting for large barometric air pressure changes, which you're going to get with large changes in altitude.
I mean, I think I would disagree with Andy because I like to disagree with Andy.
Go on.
It was great to work with him because he's very switched on and I love the way his mind works. And so we would quite regularly have robust discussions on things. and he's super switched on. I love having those discussions. And I would say I agree in some regards, but I actually think with barometric pressure, you probably can model that relatively simply with just the correction map. It's when you layer a turbocharger into that situation as well. Barometric pressure doesn't vary with RPM, is the reality. Turbocharger, you've got a restriction on the intake and a restriction on the exhaust, and then you're going to throw a throttle position in there, and so and a wastegate as well. So you layer that on top of perhaps barometric pressure changes, and all of a sudden you've got adiabatic efficiency of a turbocharger, you've got wastegates happening, and you've got throttles post compressor wheel, pre-engine. The only way to model that scenario is just layers on layers on layers, and that's where you look at manifold pressure divided by exhaust manifold pressure, and you have a perfectly consistent model across the board of the engine's efficiency.
I'll just fill in a couple of blanks here because we've gone into a topic that I'll admit is quite complex. So for those who aren't picking up what we're putting down here, we've got a turbocharged engine, and I saw this at Pikes Peak. We start, I think, at maybe 9,000 feet, and the peak of Pikes Peak's 14,000 feet. And I think the barometric air pressure the day I was there was maybe 60 kPa at the top, so 101.3 under standard conditions at sea level. So what we can do is maintain the inlet manifold pressure from the start line to the finish line if we want, provided we've got the correctly sized turbocharger. And conventionally, our ECU is going to be scheduling fuel and ignition based on inlet manifold pressure alone. Yes, we can put a barometric pressure correction on the back of that, but that's basically how it works. So while we are maintaining the same inlet manifold pressure, the bit that's easy to overlook is that as we go up in altitude and there's less barometric air pressure, less air density, we have to drive that turbocharger harder and harder and harder in order to maintain that inlet manifold pressure. As a result of this, our exhaust manifold pressure, our EMAP, that climbs. So if we're taking that into account, with, as you said, IMAP over EMAP, so our inlet manifold pressure divided by our exhaust manifold pressure, and we use that as our load axis, it kind of accounts for itself. So no problem. It's we don't need to worry about it, but it gets much more complicated to try and model that without that IMAP over EMAP. I did do this with one of our Toyota 86 development cars. Was running on an M1, and I had a development package, and I really wanted to see how this worked for myself. And I got it working really well, so changed the model so that we could do that. I will admit it gives a pretty strange looking map, because for a given fixed boost pressure, let's say 15 psi, we don't take a straight line through the map anymore. We'll come up and peak, and then of course our manifold pressure stays constant, but our back pressure climbs in the exhaust, so we sort of start falling away. So it's a little unique to tune, but I couldn't fault the drivability, and the control of Lambda was on point.
Yeah, it looks different. No doubt your mapping is going to look different. But then again, your mapping looks significantly different when you went from injection milliseconds to VE as well. And it's nowhere near as different as that.
No. Just understanding what you're going to be dealing with.
It also helps you. If you can look at that very quickly and you say, oh, I'm all out of turbo here. It starts to fall off very, very quickly for the same boost pressure. You're like, oh, wow, my VE went from 95 to 82 over the space of next to no time at all. Why did that happen? Oh, I'm just pumping hot air now. Or I can't empty the combustion chamber, ultimately is what it is. And if that explanation is great, the way I simplify that or think about it in my own sort of redneck way is your engine's an air pump, right? So you've got a restriction going in and going out. If you've got a bunch of pressure in the exhaust, you just can't empty the combustion chamber when you open the exhaust valve. So you can't there's just not enough space, empty space available in the combustion chamber when that exhaust valve closes. It's still full of hot air, exhaust, which can't be burned. So you open the intake valve, it doesn't matter how much pressure is there. If you had twice the amount of pressure in the exhaust that you have in the intake, then you didn't empty the combustion chamber on the exhaust stroke.
Yeah. I mean, another analogy for that, I guess, would actually be injector flow. So on one side of the injector, we've got 3 bar of fuel pressure. And if we end up running 3 bar of positive manifold pressure and we don't rise the fuel pressure with manifold pressure, with 3 bar on each side of the injector opens, nothing flows.
That's exactly right.
If we had 4 bar of inlet manifold pressure and 3 bar of fuel pressure, we're actually going to end up pushing manifold pressure into the fuel rail. So that's how these things work. It's a pretty simple thing, but I don't think people just don't consider that exhaust manifold back pressure unless you've dived deep into the world of turbocharged cars and actually looked at what it does.
Yeah, so that would be one area I think that if I was ZAR for a day and I could change the way we tune engines, I would say, why not just bang exhaust pressure on there and make that the norm, because it gets a much more efficient way of tuning the engine, and dynamic barometric pressure, that'll work. You can change turbos, you can do any number of things. That is a massive improvement on just the ability to make changes, see changes, the way we do things in the aftermarket.
So this sort of, I'm going to circle back to your point before that you and I are probably outliers in this market. So what we've just talked about has likely gone over the head of a bunch of people that are listening to this, which is why I tried to give that sort of simplified explanation. So where the question comes in that relates to this is, how does Haltech or any ECU brand, in your opinion, experience, balance that fine line between functionality and engineering accuracy, but still delivering a product that is simple enough that the average tuner can understand and actually get results with?
Poorly.
Okay.
Definitely, that is the challenge of every ECU manufacturer ultimately. And you do have an interesting situation, especially with ECUs. I think this is much more unique to engine management manufacturers and perhaps many other components in the aftermarket space, because the guy that designed the skills you need to design an electronic control system do not have a lot of crossover with the skills that you need to, or typically will have, to modify an engine. Modifying a motor vehicle, their mechanical skills, you're typically going to be on the wrenches in a workshop environment. To design an electronic control system, you are an electronic engineer, a relatively high level one. You have to write firmware, so you're a computer engineer, a high level computer engineer, and you're a software engineer because you're writing the software to control that electronic hardware that then goes on to control that mechanical device of an engine. And so the space between the guy that designs the product, the skills you need to design the product, and the guy that uses the product, I don't think could be further apart. If you've worked with a team of electrical or software engineers, they don't fit the stereotypical workshop engine modifier. There's a long distance apart there. Building transmissions, then it's mechanical components. At least you've got a guy that's doing mechanical things with their hands, welding, machining. That's a step much closer to a workshop environment than an electronics designer. And so when you're designing a product, engineers will engineer. And so they build something that they need or how they would need to use something. And that is so far from the customer. That's a massive challenge for ECU manufacturers, where the guy that is designing the product, and ultimately, at the end of the day, he has ultimate control over what comes out to the market in a lot of respects, because he's the guy that's designing the product. So, and that was one of my primary roles at Haltech, was to be the in-between guy to say, look, these guys in the workshop, they've got no idea what you're talking about. They don't know what firmware is. They don't care what firmware is. What they want to do is plug this thing in, belt one finger on the keyboard, and see a change in an engine bay. So we need to explain that to them in a way they understand.
I really like as well, obviously I'm a tech nerd. I don't kind of try and dress that up. It is what it is. So for me, like I want all of the control, all of the functionality. Let's make this thing as complicated as we can make it. Give me a bunch of levers that I can pull to get the best result possible. And I know that, again, I'm an outlier with that. But what I really like is when an ECU manufacturer will give a simplified version of a function that, maybe it's got one lever that goes from 0 to 10, easy. No one can get that too far wrong. But if you're a more advanced user, there's the option to go into advanced mode, and then all of a sudden we've got access to 20 parameters and we can tweak them to our heart's content. I think that's a pretty good way of walking that tightrope to me.
Yeah, it sounds like definitely, look, it's a challenge. That's a challenge that we face at Haltech, and it's a challenge that all ECU manufacturers have to walk. And obviously, the old win on Sunday, sell on Monday adage still exists within the race market. And so you kind of need to be on the fast cars, but the fast cars also have the most complex control strategies. And so you do need to have some relatively complex control strategies. And it's not so much about running the engine. That's pretty simple, to be honest. It's all about power management. It doesn't matter what form of racing it comes into. It's you've got to take in inputs from around the world, shocks, GPS, throttle, wheel speed, whatever it might be. And then you've got to do some relatively complex derivative algorithms. You say, okay, well, if the wheel speed's greater than this at this time, or accelerating at a greater rate than that, then do something about it. Those operations, especially in drag racing, have to happen quite quickly because you lose the tire pretty quickly. And so to be on the fast cars, you need to have the ability to have complex control. But to sell on Monday, it needs to be simple enough that the guy on the street with a passing interest in drag racing who just wants to run a 12-second pass can get the thing installed and up and running and not have to have a team of full-time engineers along with him at the racetrack because he can't afford that. And that's the balance. That's the tightrope that Haltech in particular walked. And we would always look at a product and say, we are not building this product for a professional motorsport team that has a team of engineers working on the product. That is not our market. You look at Motec and you would say that's not the case. They probably target their product for a race team that has access to a professional race engineer, whether that be full-time or part-time, and that's really the space they exist in, and they've done a fantastic job of that. You look at the M1 packages where you can build your own firmware. Haltech's never going to give you the option to do that because it's not their market, and it's one of the differentiators that was always in place. And that walking that line of complexity versus user friendliness, we try and bridge that gap with education. So running training seminars, YouTube channel, obviously your school, like partnering with organizations that can do training and teach people how to use the product, but ultimately it sort of needs to be as user friendly as possible. And it's a tightrope. It is a tightrope. And I do think that on some products, certainly I look at the Haltech product range now, look at the R5 and PDM, you're like, wow, super complex products, but they're edging toward that complexity model, especially with some of the control models on. You're like, oof, is the average guy going to be able to sort this out? Fortunately, they're really good with base maps.
Yeah, that's helpful.
And that can cover a lot of sins.
Yeah, I literally, not that it's one of the more complicated topics or functions out there. I literally just did a webinar earlier this week about the O2 control on the Nexus platform. And, you've got PID parameters for that. Base default values I've not needed to touch. And that's real nice.
Yeah. I mean, and if I was pulling all the levers, PID settings would be all behind a checkbox somewhere. It wouldn't be something that I would be showing to users on the norm. It would be something where you have to go through turn that thing on if you want to adjust this, because you know what you're doing. And if nothing more than to say, for the guys that don't really know what it is, it's very common to say, oh, let's adjust this thing. Oh, O2 is not working. Oh, we've got these settings. Maybe I adjust these things and see what happens. Yeah, it's like, oh, geez, maybe you don't want to do that, man. If you at least had something that was like, that's hidden. Turn on advanced functionality. Cool, let's go there. Oh, it's advanced. Maybe I don't do this. But yeah, it's a challenge.
I'm just going to take a moment out of our interview with Matt here and talk about a course that's going to be really relevant if you want to optimize your boost control. And this is one of the areas that I see so many tuners struggle with, getting good, stable, open or closed loop boost control. So our boost control tuning course is here to fix this. One of the key aspects behind good, stable, closed-loop boost control is getting your PID control gains dialed in correctly. And this is something that even experienced tuners really struggle with. But the reason they struggle is more to do with a lack of understanding of what PID control is, rather than it actually being outright difficult. Once you understand how it works and you're presented with a step-by-step process for optimizing the gains, it is actually relatively simple and easy to tune. We teach you all about PID control, how it works, and give you some practical analogies so you can actually understand what the different terms mean. You'll learn about the fundamentals of boost control, how a wastegate operates, how to select the correct spring for your wastegate. You'll learn about the differences between internal and external wastegate actuators, boost control solenoids, solenoid operation, and most importantly, boost control plumbing. For some reason, this is something that I see people get wrong 99% of the time, and there's absolutely no excuse for this. You'll learn about the differences between open and closed loop boost control and some of the more common boost control problems that you'll face. We then move into the boost control tuning process. You'll learn about the configuration of your outputs. You'll learn about setting up your open loop or feed forward base duty cycle table, and then we'll move into tuning your closed loop control. Once you've gone through this course, boost control issues will be a thing of the past, allowing you to get stable, accurate boost control on any ECU on any turbocharged engine. This course is normally valued at $79 but by using the coupon code MATT25, that's MATT25, you can get $25 off this course. You can still break that payment down into as many as 8 individual weekly payments at the checkout, and of course you are still protected with our 60-day no questions asked money back guarantee. I'll put a link to that course as well as the coupon code in the show notes. Let's get back to our interview with Matt now. All right, let's park ECUs and move on to the second chapter of your life, which is your current position. So you're now working for Turbosmart. How did this opportunity come up?
Yeah, so as I mentioned earlier, about 18 months ago, Haltech was sold from an Australian company to Race Winning Brands in the States, which I think was probably the right move for the company. It had grown to a point where the US market is definitely the big growth. Our previous company owner heading toward retirement age and really probably needed to invest quite a bit of money into the company to handle that growth, with especially after COVID, with the requirement for new machines and a new space and the investment that's going to require for a company to grow. We were already well beyond capacity in the building and the machinery that we had. And so it was probably the right, and obviously coming out of COVID, the market was good. So the numbers look good. The company sold for a good value, and it was a lot of things lined up for him. And I do wish him luck, sort of post Haltech, because he's a great guy, and obviously working for him for 20 years, he's like a father to me. And so it was the right move for the company. Whether it was the right move for me or not, it's a different story. But I lasted about 8 months or so under the Race Winning Brands banner, and I had some time off in that and sort of thought, is this where I want to be forever? And I'd actually taken long service leave and had some stuff go down in my personal life. My brother-in-law passed away, and there's some stuff happening in family, which is really, really hard. And I got back from my long service leave, and the general manager at Haltech sort of sat me down. We had a bit of a discussion and decided that the direction that Race Winning Brands were going and what I thought was the right direction for the company from a sales perspective were probably a little bit different. And they're just different mentalities. So
I mean, it's always going to be tough when there's a complete change of ownership, because there's always going to be differences of opinion in the direction that's best.
correct, yeah. And you've got a venture capitalist. You got that they want return on investment. I understand that they're moving much more to a WD model in the States and selling. I mean, that Rebel LS ECU, look at the price of that thing. I mean, it's so affordably priced. I don't know how they can build that thing for the price they're selling it. I know they're going after a volume market. I personally look at that and go, I don't know that this is the best business strategy for the company to be pushing out high volume of a complex product at a low price. How do you support that? How do you stand behind it? That was what we built the Haltech brand on. That was always sort of my strategy within the roles that I had was supporting the workshop customer and building quality products, standing behind it. And that was the unique selling proposition. Selling volume, the product's just as complex. It's the same product. So it's just as complex as how do you fund that support when you're giving big discounts to WDs? But I guess Race Winning Brands have their network to sell into and whatever. And so there was enough difference of opinion there. And I was sort of at a point in my life, I was like, you know what? I don't need this. We differ opinion enough that we came to an agreement, and I went my separate way. And that was okay. It was hard to leave a company after 20 years where you're so invested, so much of your identity is tied up in the place. It was fantastic to see. I hadn't been out the door 20 minutes before I had Nick and Chris and Stu from Turbosmart here on the phone saying we should have lunch. And so it went from being sort of a situation where I was feeling a little bit like, oh, geez, what do I do next? I guess everybody, when they go through, they leave one job without a new one to go to, there's a bit of a feeling of, oh, shit, what have I done? Have I done the right thing?
Scary times.
Yeah, it can be. Yeah, you sort of tend to doubt yourself. But it turned out all right. So I came over here. It was literally like 400 meters from the Haltech office. It's not far away to Turbosmart, and sat down, and it was a good time in regards to product development. Turbosmart was relatively deep into realizing, holy shit, we've got this turbocharger project that we're working on that we probably need some additional staff, because the staff that were here working on the project, we had all our other products to maintain as well. We had Boostgate underway, which is the cold side boost control, StraightGates that had just come out, and this turbocharger project was a whole new project that hadn't necessarily been probably resourced appropriately. So it was a good time for them. They were looking for someone anyway, and they had advertised and not been able to find anybody that sort of had the experience that they thought they required. And so when I became available, it was a little bit of a like, oh, someone that knows something.
Yeah, always helpful. All right, let's just rewind. I'm going to just make this bold assumption that everyone listening has heard of the Turbosmart brand. I mean, it's international. It's, in my opinion, one of the most premium products for the areas in the market that they service, and certainly it's a product that we have on literally all of our cars. But just give us maybe the 30,000 foot view of what Turbosmart is, where it's based, staff and products offered.
Yeah, so Turbosmart similar to Haltech in that regard. It's based here in Australia, literally like a couple hundred meters from each other in the factories in Western Sydney. But we design and manufacture blow-off valves, wastegates, fuel pressure regulators, now turbochargers, and we've been around for nearly 30 years now. So good Australian success story. We've got, I'm looking over the window here, I think there's about 15 CNC machines running in the factory down there at the moment. So all of our hard parts are manufactured here in-house. I think we've got 60 something staff. We've got offices here in Australia, we've got an office in the US, UK, and in Europe. So 4 locations. And I mean, primarily the 3 product lines of wastegates, blow-off valves, and fuel pressure regulators have been the bread and butter for the majority of that time, and then turbochargers has just come online this year.
Released at SEMA 2023 from memory. Well, announced at SEMA.
Yep, announced. I don't think the first one. I think the first one shipped in December 2023. So I'm going to call it beginning of 2024. But
so we're a 6 or 7 month old product.
Yeah, which
okay.
I don't know. I think I've aged about 40 years in that 6 months, but it's been a bit of a ride. But it's been a good one to be a part of. But yeah, so that's us. Obviously, I think I sort of think back through the history of Turbosmart and think, okay, what put Turbosmart on the map? I mean, blow-off valves, yep, they were definitely a part of it. Wastegates, everybody knows Turbosmart for external wastegates. We've got fuel pressure regulators, I think in Australia, very well known for FPRs, but they're not really a sexy item. It's not something people go, I've got a Turbosmart FPR. It's sort of one of those items that sits in the engine bay. It's really popular for us, but nobody necessarily talks about your fuel pressure regulator, which does my head in a little bit because I'm like, man, this is probably the most important thing. One of the most important devices on your engine is actually controlling the fuel pressure.
100%. We'll get into each of those items in a bit more detail because I think pretty much just like you've said with the fuel pressure regulator, it's an overlooked, I need a fuel pressure regulator, I'm going to put one on and I'm never going to think about it again. But as we'll get into, there's some subtleties and some not so subtle aspects that really affect the end result. In terms of your role at Turbosmart, what does that look like? What's on your business card?
My business card says I'm the Group Product Sales and Marketing Manager, which basically means I oversee all 4 subsidiaries in regards to the marketing side of things. So when you see marketing material comes out, that not doing the work, approving the work, but ensuring that we are on brand and keeping things in the same direction. So big picture marketing things, obviously, that we market the products that we sell. So that's where the other 2 sort of words on their business card come from. So product wise, I get involved in product's an interesting thing when you're a manufacturer, where you design and manufacture your own products, because the world is your oyster. Truthfully, with some of the best engineers in the world here, they can make anything, literally anything. And we've got a lot of customers. And so you do get a lot of requests for, can you do this? Can you do that? Well, the answer is, yeah, we can. The question is, should we? Is it the most important thing for us to do with the limited resources? And that's where a lot of my role, my time is spent, is looking at, okay, what are all the possible things that we could make? What makes sense? What can we repurpose maybe from an existing catalog part? There's a lot of blow-off valves, OEM replacement blow-off valves that are relatively simple, different flange or a different spring or whatever, and we can make an OE replacement product. And then of course you've got your new product development, which is things that might be new to the market or just new to us. So turbochargers, not new to the market, but new to us as a company. That sort of falls under my mandate. And then we've got things that are just totally new to the market, that things like the StraightGates and boost gates recently, that there's just nothing else like it out there. That all falls under my responsibility.
Okay. I think just in that respect, your success is often defined by the things you choose not to do just as much as the things that you choose to do. All right, let's dive into probably the first product that I sort of think is Turbosmart sort of synonymous for, which is the external wastegate and also internal wastegate actuators. In terms of that, it's a product that's quite interesting because I haven't really seen much change in the poppet style wastegate, which is the conventional wastegate. Obviously, we'll talk about the StraightGate in a moment and electronic wastegates, but nothing's really changed. So what separates Turbosmart from other quality manufacturers in the industry, such as Tile, for example?
So a lot of that, and you think to look at from the outside, not a great deal has changed, but we're on, I think, a 6th iteration of external wastegate poppet style valve. So a lot of that comes from improvements in flow design. So for the same size hole, depending on valve geometry, the geometry within the gate itself, the housings, those sorts of things, the same size hole can be up to 50 or 60% more flow on a well-designed wastegate.
So we're not just worried about the size of the valve. There's a lot more to it.
Correct. That's exactly right. You could look at a 60 mil or 50 mil gate, and two different manufacturers will flow significantly different amounts. The other thing you want to look at is not just necessarily the total flow, but average flow. So they're two totally different sort of metrics to look at. So being able to optimize and balance out the average flow rate versus total flow or maximum flow there's a lot of design work that goes into that. And then of course you've got linearity. So as soon as that valve pops off the seat, you don't necessarily want to leak a shit ton of air. You kind of want a relatively linear response. So whilst you look at an external wastegate, they're all the same thing. There's 50 mil valve in there. The thing pops up at a certain pressure and lets some air out. The idiosyncrasies and the detail that goes into the fine airflow dynamic to get a nice consistent balance of linearity, maximum flow rate, and then average flow rate. There's probably a lot more CFD and design work in that than most people realize. Then there's the material properties. I was shocked at the amount of different materials and material coatings and processes that the valve and the body has to go through to do millions of cycles at 1800 degrees Fahrenheit and stay together. That's one of the big differences that you see on the market between the quality manufacturers and perhaps the less quality manufacturers is you can buy a wastegate that might look like one of the quality ones, but man, that valve is made of chocolate. The thing lasts for 9 months, and all of a sudden it's not sealing anymore. Why is it not sealing anymore? Material quality is just not there. That's one of the reasons. One of the areas you can cut cost is you don't put expensive coatings in the material. You use cheap materials. They look the same, but when you put it together, but once you start using it, you get 6, 12, 18 months into operation. One's working like it was the day you bought it, and the other one is just useless.
I mean, you don't really want to be playing around with half-assed products when it comes to boost control, because these can make or literally break your engine, which, I mean, an interesting aspect that you, as you were speaking there, reminded me of. I don't see it so much anymore. I'm sure it's still prevalent, but there was a time when knockoff wastegates out of China or Taiwan, I don't really know where they're coming from, was really prevalent. And I mean, sometimes you'd actually would have both products side by side, and it would take 5 or 10 minutes of searching to find the differences. I mean, these companies are making such aesthetically perfect replicas. Why the hell can't they also make them operate the same? But I guess from Turbosmart's perspective, it's great that they can't, because otherwise you'd probably be out of work pretty quickly.
Yeah, that's exactly right. And you look at the cost of one of our products, you think, oh wow, that's pretty expensive for what it is, and I can go and get the knockoff one for $100, and you're selling something for $600. Can they be that different? I'm like, yes. The answer to that is yes, they can.
Yeah, no, I saw plenty of counterfeit wastegates on customers' cars, and they do not work like the real deal. Or maybe they do out of the box, but like you were saying, yeah.
They do out of the box, but once you heat cycle them, all of a sudden, and it's just frustrating. And it's one thing when you buy a $100 valve off eBay, you're not getting a legitimate product, and you put it on, and in 12 months' time, when you've got to take it off, throw away, either put another one on or put a genuine one. That's on you. What is more frustrating is when somebody thinks they're buying a genuine product and they have paid maybe just $30 or $40 less than the regular price for a knockoff. That's the worst, because the guy's actually paid the right money basically for a knockoff product, and they do look good enough, and that's the one that really gets you. That's super frustrating when that happens.
Yeah, absolutely. All right, in terms of sort of the development and iterative improvement with these wastegates, the other options that have come out from Turbosmart in the last few years, maybe 5 years now, is the E-gate, so electronic wastegate. I mean, this in and of itself is nothing new. I'm guessing you took your cues here from the OE manufacturers who have been running electronic wastegate actuators for a while. What's the advantages, or maybe even pros and cons, of electronic wastegate control over pneumatic?
It's a good question. We get asked this question a lot, actually, and it's interesting. When we sat down, and I get this story, I wasn't here at the time. Obviously, they've been out for 5 or 6 years. So I get the story though, and I know the backstory. When the design engineers sat down and decided that this is the future in a lot of respects, it was actually in response to a need, which is how so many products are developed. A number of customers, specifically in the drag racing world, using CO2 boost control, it was frighteningly common where you'd hear, we lost the race because we didn't turn the CO2 on. You're laughing because it's happened.
Yeah.
You're reminiscing. I remember that time, my Evo, I did that on that line. Yeah. it happened a lot.
Running out's a real problem too.
Yeah, running out or running low pressure, or running out is an interesting one because you get so long out of a bottle, you just forget to think about it.
You become blasé, yeah.
Yeah, you get blasé about it. That's right. Or someone just forgot to turn the damn thing on at the pit. Like, that happens all the time. So it was like, all right, OE's gone electronic probably the future. What does this look like for us? And we had really targeted that product and expected that product to end up almost primarily and solely in the drag racing CO2 boost control space. It was really designed to be a competitor to CO2 control. Cost basis, similar money, because by the time you've got a bottle and lines and a AMS 1000 or whatever 2000 to control the thing, you're not spending any more or less money on an electronic gate than you are on a CO2 setup. But you did have the advantage of A, there was no bottle, so you just couldn't get that one wrong. But B, most people don't think about, especially on a drag car, when you're on the two-step, on any pneumatic valve where you've got a spring pressure or any sort of mechanical pressure on the top of the wastegate, you've got exhaust back pressure or drive pressure pushing up on the bottom side of the poppet valve. There's a significant amount of pressure variance in the exhaust manifold. You think you're on the two-step, you hear the thing popping and banging all over the place. Well, that's moving that valve around significantly. So if you actually look at the valve position on the two-step, it's moving all over the place, which is okay, I guess, but it's not really okay, because when you release the clutch, depending on the position of that valve, you get the consistency of the first 60 feet starts to come in question. And so that's where the electronic gates, they don't have that issue. I mean, you ask for a position, it goes to a position. Doesn't matter what's happening in the exhaust. You pop and bang all you like. The position is
not going to open, not going to bounce off its seat.
That's exactly right. So not only did it solve the issue of you forgot to turn the CO2 bottle on, but it is a more consistent control strategy, especially when you're coming out of a launch two-step, the first 60 feet of a drag strip. And that's really where it's found its home. It's been most appropriate. People are using them elsewhere. You do see them show up in motorsports around the place, some circuit racing, some Le Mans cars even running them. I shouldn't have told you that, but
don't worry, no one's listening.
No one's listening. Yeah, those guys aren't listening. Yeah, I'm not telling you who it was, but
in terms of speed of operation, maybe if we talk full travel, which is probably irrelevant because it's almost never doing that. But CO2 versus E-gate, what's faster?
Yeah, well, it's an interesting question. In the real world, I don't think there's a difference, to be honest. I have seen, you see it all the time. I see it on the internet. People send me this same clip all the time of someone's got an E-gate on the bench and someone's got a pneumatic gate on the bench with CO2 hooked up to it. You change the target position through an ECU and the pneumatic gate moves quicker than the E-gate. That's all well and good, but what you're not accounting for there is you've got no drive pressure pushing up on the valve of the pneumatic gate in that situation. That's sort of not a real world scenario. And secondly, it's very rare that you are wanting to move the valve instantaneously.
You're only looking at small instantaneous movements really, or you're ramping up and down.
Correct. You're not going full sweep. That's exactly right, yeah.
Yeah, so a full, like I just mentioned before, a full travel sort of deflection is probably something that will never happen.
Never. That's not doing boost control. That's
If you wanted to dump all of the boost, that'll do it. But yeah, probably not a situation where we're going to actually be looking for that to happen.
Yeah, that's exactly right.
All right. So under real world conditions, same.
Same. That's exactly right. You just have a little bit more precise control as the thing comes off the seat, because you don't have that sort of mechanical resettling. The other thing with a pneumatic valve is as soon as you pop that pintle off the seat, the pressure behind in the wastegate itself changes, because now you've got flow moving into the backside of the valve, and so your pressure differential across the valve itself actually varies as soon as you pop the thing off the seat, and so there's variance in movement in that.
Now, I think that drive pressure behind the valve or on the underside of the valve it's just like we were talking about earlier with EMAP. Well, it's exactly what it is, but people just completely forget that that's a thing. And this sort of comes into, I guess, what I see as one of the advantages with the E-gate is that pressure no longer matters. If you're using a conventional spring, so we've got boost pressure from the inlet manifold being forced onto the top of the gate, trying to close it, force it down, or CO2 if we're running CO2, and we've got the drive pressure or EMAP trying to force it open. So what that means if we just talk about conventional pneumatic control, no CO2, if you've got a 10 psi spring in your wastegate, first of all, that may or may not actually give you 10 psi because it's going to depend on how restrictive the turbo is, how much back pressure you've got trying to force the gate open. But what I'm getting at with this is because you've got that drive pressure, which is going to increase as the boost pressure and RPM climb, you're going to have a top out of what the maximum boost you can achieve is going to be. And, maybe you'll go from 10 to 25 PSI, but chances are you're never going to go from 10 through to 35, 40 PSI. So there's a limit in the minimum to maximum range of boost you can achieve, correct?
On a spring, yeah. And depending on, there's a few different options in regards to how you arrange the solenoid and the ports on the top of the wastegate and top of the valve. But ultimately, you're right. Where even with controlling pressure to top and bottom side of the diaphragm, you still end up in a situation where you either one of two things. Ultimately, what ends up happening is you trade off accuracy or repeatability for range.
You're talking here about using a 4-port solenoid instead of the more conventional 3-port.
Yeah, that's right. So yeah, for a 10-pound spring, you might be able to go, 10 to 25 pounds on regular sort of 3-port solenoid. You might get that 10 pounds to 45 or 50 pounds on a 4-port solenoid setup. But for every additional pound of range you get, you kind of lose resolution in your boost control. And it's just the nature of the mechanical relationship that you have inside the wastegate. So on a poppet style valve, that's the case. That's not the case on a StraightGate because it's a butterfly valve, and so the drive pressure is not pushing the valve open because it's equalized across both sides of the butterfly, and so that's much less of an issue on the StraightGate style wastegates.
Right, let's finish up with poppet style before we move on to StraightGate, because that's something that I wanted to learn about. But again, coming back to this E-gate on a poppet style, that kind of eliminates that range limitation. We can kind of target within reason any boost pressure that we want, provided obviously the wastegate can bypass enough exhaust gas energy to achieve that. Well, there are some complexities around running this gate though. I think when it was released to market, I remember I did a review on that product at SEMA where it was launched, and the obvious problem that I saw is this thing can draw up to 20 amps when it's going for a full scale deflection. And the problem is, of course, at the time, and really nothing's changed, the ECUs mostly were using AMP superseal connectors, and a terminal on that can maybe support 7 or maybe 8 amps. So there was this disconnect. In time, there's been solutions to that, but can you talk us through that problem and the solutions there are?
Yeah, definitely. I think that's well identified, and that's actually one of the things that we as a company at Turbosmart have identified with that product range as well, is we released a product that ultimately was tricky for the market to use because there was no control strategy out there, because like you said, you need 20 amps to run the thing. You can't run it straight out of an ECU. You need some sort of an external driver. And we did have the black box under development, which is our own electronic control box, but we didn't have that available at the point in time where we had released the E-gate. And so there was probably maybe 12 months or so in there where we had E-gates out on the market, and we had to really rely on the ECU manufacturers to write firmware and code in their ECUs to run the thing. But to drive that motor in Fury as fast as it can possibly go, you probably need about just over 20 amps of burst current. And that's a lot. You can push that through one of those AMP pins, but you can't do it for long. And so, yeah, it was a bit of an issue. And certainly being a H-bridge push-pull driver, I know I was on the other side of the fence when the E-gate came out because I was working at Haltech, and even the that's it. Even the drive-by-wire motor controller that is in the Elite Series ECU, which was sort of what was out at the time, is not capable of doing 20 amps straight up. Won't do it. It'll burst at maybe 8 amps and peak at 4.5 or something like that, which is plenty for a drive-by-wire throttle. But it's not that it won't move an E-gate. It's just that it won't move as fast as it could possibly go. And so that was definitely something that I think Turbosmart knew that would be the case, but it's been a relatively long time to get that issue solved, in that it really meant that manufacturers, Fueltech, Haltech, Motec had their dual HB driver that could work out of the box but required firmware. They had their M1 build package, but end users were having to write the firmware, and that was a little bit tricky. So you kind of left the control strategy in the hands of anybody really in that case, not necessarily unqualified, but people that don't necessarily have close access to us as the manufacturer of the gate, telling them, say, hey, don't park the thing too hard because you've got a worm gear in there and that can drive closed and you'll never open the thing again, which is definitely, it's a very real issue, and there's a calibration process that all ECUs now will put the E-gate through, which will basically monitor the current to the motor in the calibration process and say, all right, look at the position, look at the current, apply a fixed pulse width worth of energy into the thing, how much current did it draw, and that's how it figures out when's it on the end stop. Don't put too much current into it. That's sort of how it gets its positioning information. And then there's some relatively tricky firmware in the background that says, okay, obviously it's a mechanical part. It grows with temperature, and so as temperature increases, so on initial startup or calibration, you want to offset that closed position by a small amount because of the growth in the actual valve itself. And so I know that Haltech and FuelTech and Motec are all aware of this, and they calibrate that. That goes to their calibration procedure.
I guess it's one of those things, though, sort of it's a chicken and egg situation. Do you wait for the ECU market to provide solutions for a product that they don't even know exists, or do you bring out the product and then wait for the industry to catch up?
Yes, and we chose bring the product out and leverage on the friendships and relationships that we have. Fortunately, being Sydney, you've got Haltech around the corner, you've got Mtron just up the road, Motec's just down in Melbourne. If you're going to be in a market to launch a product that requires an ECU manufacturer to do something for you, it's nice to be done here, and we have really good relationships with the guys at FuelTech through our US office. So that was probably the other big player, and so all four of those guys came on real quickly, and so that's worked well, and it's really helped the product to be successful. But certainly in the early days, I mean, there's some well documented failures out there where blocks have been split in half on the starting line and things like that. And look, we may as well talk about it. It doesn't matter what wastegate you're using. The first rule of boost control is always have a boost cut.
100%.
It's one of those things. And look, I understand you break an engine, you want to blame somebody, but you don't break a block in half when you've got boost cut set to anything. So, it's one of those things. The big learning curve from our end was, okay, when you release a product, it's always going to be more successful if you can control the whole value chain and you can control the whole tuning chain. So, but look, it is what it is. We've released a product that's been well accepted in the market, and all the big ECU manufacturers now have integrated it directly, and we've moved on effectively to the second generation now with the StraightGates, also available in electronic and pneumatic, and that only. I mean, most manufacturers actually had that in their firmware before we even released it to the public, so it's been a good thing.
Okay. I'm glad that you did talk about the failures. I think I've had two guests on the podcast. One, there's the reference to the block split in half. I remember that one distinctly. Another one who didn't really want to talk about it on camera, and I won't name the car that was on, but a reasonably high-profile car that had problems with the wastegates from a heat control standpoint. And I'm just interested, again, without trying to throw you under the bus, but I think that it's valuable to talk about these things. Not everything always goes perfectly, and we learn from what fails. But is the heat, obviously you're putting some electronics in a very, very nasty location with a lot of ambient heat around them. Is this a problem with the design and the electronics, or is this more of a packaging issue and more work needs to be done around heat shielding, etc.?
It's a bit of both. I mean, ultimately, anytime you've got electronics involved, there's a finite temperature which the thing is going to be able to run at. Solder melts at a certain point. That's normally the limitation, and that's been the limitation when we've had temperature-related failures with electronics. That's probably packaging more than anything else. When I say packaging, I mean packaging with the engine bay. You've got heat shields in there. There's water cooling in the body of the electronic gates. It's really a matter of, if you stick the electronics sort of tucked under an exhaust manifold where the heat can't get out of the engine bay, you're going to have the same problem across the board. Doesn't matter what gate you put in there. You do have to think about the thermal management of the entire package. So that might be heat shielding, that might be ducting. It's unfortunate, but it's a reality, and we know that from racing. We know we run heat shields, we duct heat to brake ducts. We vent brake ducts, we vent the engine bay, we run air all around the engine bay to try and cool things down. So yeah, it's 6-1, half dozen other. There's plenty of successful applications of that product where they're operating in 24-hour races without an issue at all.
Yeah, I guess that was the other side to my question, was this is a product that is viable for a road race application, and an endurance application is not solely focused on the sort of high power pro mod style or sport compact drag racing.
Yeah, it has found its home in some of the endurance racing. It's interesting. You run up against a whole other set of problems with endurance racing, and this is probably not just with the E-gate, but it's probably easier to do with the E-gate, which is if you don't close the valve at all, then that's always got a lot of heat on it. There's no opportunity for the valve to release heat into the seat and into the body of the wastegate. And so definitely, if you run a 24-hour race and you never close the valve, then it's going to melt. That's the reality of it. So we've learned that one the hard way. But again, that's application. You wouldn't do that with a pneumatic valve. Will do the same thing. It's not as though the valve itself is any different in the electronic application. It's just that in a pneumatic valve, that wouldn't happen. You would always seat the valve mechanically when you back off and all those sorts of things. So yeah, it's one of those things, application specific, and you say, oh, is that a inherent problem with the valve? No, that's a control strategy, and you've got to work, within the mechanical limitations of the mechanical components in there.
All right. StraightGate. Give it to us straight. What is it?
Well, I mean, quite simply, it's replacing a poppet valve with a butterfly valve. And so rather than a poppet valve and the air turning 90 degrees, it's a butterfly valve, very much like a throttle body. Obviously, you're not going to stick a throttle body in the exhaust because it's going to melt in no time at all. So
Next best thing, though.
Yeah, next best thing. If you're on a budget, send it.
I mean, this seems like a pretty logical approach to flow control. I mean, I could be speaking out of turn here, but I don't believe it's been done before.
Yeah, correct. It's an interesting one. I can't answer the question as to why this wasn't done, 20 years ago. I think the right angle casting is with a poppet valve it's a great idea. It makes sense for a poppet valve, right? So you do wastegate with a poppet valve. It's always been done with a poppet valve. But as soon as you go to an external valve, why wouldn't it have been done with a butterfly? I don't know. There is some challenges around sealing the shaft, but it's no more complex a challenge than sealing the shaft in a turbocharger, for example. So it can be done, and it is being done. So
now, I'm interested in. I've obviously tuned a lot of cars, and hence I understand a reasonable amount about the airflow through a butterfly valve versus its opening, and it's very, very non-linear in so much as when the valve is completely closed and we first crack it open, we get quite a significant or sharp rise in airflow versus butterfly opening degrees. And then the further we get through the travel, sort of from maybe 80 to 90 degrees of travel, there's little to no real change in flow. I mean, I've never had the ability to check the flow versus valve lift in a poppet style wastegate, but my gut says that it's more linear. Am I right or wrong?
Which one do you think's more linear?
I would have thought the poppet style would have been more.
Not at all.
Really? Okay, that's really interesting.
Not at all. Yeah, no, not at all. No. Yeah, a poppet valve is significantly less linear. And you think about it, as soon as you pop that valve off the seat, the entire circumference, the entire area of the thing, and then you move the thing 2 millimeters, 3 millimeters. Once you're about 4 millimeters off the seat on a poppet valve, you've gotten most of the flow.
Sure. Okay.
Versus a butterfly style valve, you've got a much more linear flow to position opening. So whilst I agree with you, it's not linear, but it's much more linear than a poppet valve from all of our testing. That's one of the actual advantages. There's two major advantages to a StraightGate to a butterfly style external wastegate. The first one is obviously just that, the linearity, the position to flow is much more linear. And the second one is the drive pressure. Because you've got a shaft down the center of the blade, it's equalized across both sides of the butterfly.
Gets rid of that problem we were talking about before with the poppet valve being forced open by drive pressure.
Correct. That's exactly right. That just doesn't happen. And so your boost control you've got a much greater ability to get, anywhere from 5 to 50 pounds of boost using regular 3-port boost control, because it's all on the diaphragm, really.
Yeah. Okay. So what are the complexities around speccing a spring for, let's say we're going with a pneumatic style of control with a StraightGate? What are the complexities around choosing a spring that's suitable versus for a poppet style? What do we need to know?
It's quite different. Yeah, it's quite different to a poppet valve. And this is one of the areas that pretty much the first time everyone uses a StraightGate, they're expecting to put a similar spring in the gate to a poppet style gate. But because you don't have that drive pressure, you almost need to halve the spring to get the same boost pressure. So where you used to putting, say, a 10-pound spring in there to get 10, 11, 12 pounds of boost, you really want a 5-pound spring to do the same thing, because you don't have the drive pressure pushing the exhaust valve back up from the exhaust. So you drop your spring rate down significantly. You really only need enough spring to close the valve on a pneumatic application. Obviously, with the electronic StraightGates, it's electronic, so that doesn't matter. Yeah.
All right. Is there any real downsides? Just when you were saying sort of 5 to 50 psi, straight away I'm thinking the same situation we get with the 4-port solenoid where we lose resolution in terms of, instead of a 5% increase in duty cycle to the solenoid giving us 2 psi, maybe now it gives us 5 psi. Is there anything to that, or am I off the track?
No, you are on track. It's probably that's one area that is, again, significantly different with the StraightGate is your PID control settings are totally different. Again, you're not fighting exhaust back pressure. So if you were to run, and probably the best example is CO2, because you're running big boost, you've got a significant level of exhaust back pressure pushing up on the bottom of the valve. If you're running 90 pounds of boost, you can expect to have at least that in the exhaust or close to that in the exhaust pushing up. And so you've got to have quite a lot of CO2 pressure on the top to move the thing around. You've got to have more than that to move it around plus the spring. So that's not the case with a StraightGate. So you don't need to be stuffing 100 pounds of boost on the top of the thing to move it around. You still need the regular, you only need 10, 15, 20 pounds of CO2 pressure to be moving the gate around because you don't have the drive pressure pushing back on the shaft. It's exactly the same control. You could set it up on the bench and it's exactly the same PID and control parameters as it is in the vehicle because you're not fighting drive pressure, which is variable with boost. So that's totally different. Your PID settings are going to be way less aggressive, half of them, quarter of them, 1/10 of them, of what you're used to seeing in poppet style control. And the higher the target boost goes, the more that comes into play. Mainly because your regular boost control is getting more and more aggressive the higher the target boost. Just because you're fighting against the drive pressure.
That all makes good sense. Are there any real downsides to a StraightGate? I mean, are we going to see, in your sort of expectations, are we going to see a shift away from a poppet style gate now towards these StraightGates?
From our end, it feels a bit that way. I mean, obviously, you've got a significant number of vehicles that are set up for poppet style wastegates. I don't think they're not in the next 20 years. I don't think they're going away. That's just the nature of the industry. On new builds, I think that the sales crossover that we're seeing, a lot of the larger gates, the 60mm gates, people are moving over toward the StraightGate for all these reasons. So it's definitely shifting on the bigger stuff over to a StraightGate because the flow linearity and for the same size hole, you get more air through. It's just better airflow dynamics.
Just from the discussion we've had so far, it would seem to me that this would lend itself most ideally towards a drag race application where we're running big boost. Is there an advantage? I mean, it's the old adage of if it isn't broken, don't fix it. The poppet style valve, well developed, well understood. If someone's got one on their car and it's working, are you going to recommend a change to a StraightGate or just leave it as it is?
Don't fix it if it ain't broke. I mean, that's my advice generally. If you've got one of our regular poppet style wastegates on there, you're not having any issues, it's operating under the conditions you want it to operate, it makes no sense to do a whole bunch of work to make no gain. But if you are running those limitations of you want to run lower boost and higher boost, and you want to be running 5 pounds at one point and 50 pounds at another point, and street cars these days, especially here and probably there in New Zealand, these guys are running stupid amounts of boost. They want to be able to drive on the weekend. They've got an exhaust silencer on the thing and think, oh, this thing will cruise around with 300 horsepower and they've got 1400 horsepower under the bonnet. That's all boost, right? That's how that happens. And so for those applications, I definitely think we'll see more and more StraightGates coming in. Maybe circuit cars, there's probably a reasonable use case to have all the boost available, but drop it back when you need to. So I do think that in most forms of motorsport, you'll see the progression over to StraightGates. If it's just a regular street car where you want to target, 10 pounds, 12 pounds, 15 pounds, it's probably not worth the work.
Yeah, okay. Right, one more question on this. I think we could go on for another half an hour, but there's other topics I want to discuss. But one of the big questions that always comes up is wastegate sizing. And this one, I don't see it being a very easy topic to answer, but give me your take on how does a customer with XYZ engine, XYZ turbocharger wanting to run 20 psi, how do they go about choosing the right size wastegate the first time?
The first thing you got to remember is wastegate decreases boost. It doesn't increase boost. The most amount of boost possible is no wastegate. That's the very first thing you need to realize. So the question is not asking yourself how much boost do you want to make. It's how much boost do you want to lose. So, I mean, when it comes to sizing a wastegate, it's more a matter of what the range of boost is that you're looking to run. Then you have to layer on the size of the engine. It's really about mass flow. So if you're running a 2 liter engine and you want to run 40 pounds to 20 pounds, that's got a certain amount of mass flow you've got to bleed off. Exactly the same scenario where you want to go between 20 and 40 pounds, but you're running a 5 liter or a 7 liter engine. Well, you need 2 or 3 times the amount of wastegate to bleed off, because for every engine cycle, you're pushing twice as much air through. So there's no one size fits all answer, but it is looking at the particular application, which is going to come down to what's the maximum amount of boost you want to run? Okay, that's gate closed. What's the minimum amount of boost you want to run? That's gate open. Okay, how much boost do we need to bleed off? What's the size of your engine? And that's going to start to narrow down the range of available options. Do you need 1 gate, 2 gates, where they need to be? So it isn't an easy answer. It's more application specific.
Yeah, that's. I'm glad that you sort of got through the fact that there isn't a black and white one size fits all answer. But I'm going to guess here, for the uninitiated who don't have any data points from previous experience and they're looking at wastegate sizing, they're going to be able to contact Turbosmart's support. And you guys probably do have the data points on, we've done 100 of those engines with that turbocharger combination and that boost target, and this is the gate that we know works.
Correct, and not even us. I mean, workshop. If you don't know the answer to that question, you've probably got a workshop that's doing the work for you. That guy knows the answer. He's like, I've got this 45 mm gate in stock. It works. That's where it's going to go.
Yeah. One of the other things I will just point out here, because I see this time and time again, there's 2 reasons why the wastegate won't work, irrespective of how good and properly sized the wastegate is. One is it's the whole system, so we also need to consider how the wastegate integrates with the exhaust manifold and how the flow is prioritized to the turbo or the wastegate. And what I mean by that is, just briefly, the exhaust gas is super lazy. It wants to go in a straight line. It doesn't really like deviating from that. So if you've got the wastegate coming off the manifold so that the exhaust gas has to do a 180-degree turn, it ain't going to like that. And your no size of wastegate is going to get really good control, and you get this sort of tendency to exponentially increase in boost the further you go through the rev range. That's not going to work. It's not the wastegate's fault. And the other one, and I just see this time and time again, and there's no excuse for it because you just read the manual, is getting your boost control plumbing around the wrong way. And I reckon
I can't deal with that.
I reckon if customer built cars that I tuned, 99 times out of 100 they'd get it wrong, and it's almost like guaranteed. Which comes back to your previous point: set a boost cut.
That's every conversation when it comes to talking about boost starts with the same thing. The first rule of boost control is always have a boost cut. It's that simple, because it costs you nothing. Every ECU has got it. It's not. It doesn't matter what kind of boost control you're doing. There's a boost cut available, and if you got it wrong, or something goes wrong, or you lose a line, or insert any number of excuses here, it saves the engine. And so, what's it going to cost you? Nothing.
Well, that's one of the setup steps in our 10-step tuning process is engine protection. Set a rev limiter, set a boost cut, make sure that they're appropriate. And you know what? To start with, make sure they're super conservative. And then once you know everything's working, then we can start lifting them up out of the way.
Absolutely. Yeah, no, you're spot on. That can't be emphasized enough.
All right, we have done wastegates to death, and we're getting short on time. I've got about a million other topics that I wanted to discuss, and I'm going to break out of order here so that we don't end up running out of time, because for me, the next exciting or interesting topic to talk about is the Turbosmart turbochargers, which we already kind of touched on. I get for Turbosmart, with the range of products you make, this kind of is the obvious next choice to kind of go full circle and we'll close that circle. It's kind of a bold one though, and this is a kind of a saturated market at this point. There's so many quality turbochargers coming out of so many quality manufacturers. How do you differentiate yourself from those? And how bold of a move was this?
I agree. Super bold move. I mean, for me personally, I entered the chat after a lot of the decisions had been made. So the project was underway, and I got tasked with picking it up, which has been great. But it's definitely a bold move. Things you need to consider though is every single day that Turbosmart has been in operation prior to selling turbochargers, we would get the question, "Oh, you guys sell Turbosmart?" turbochargers? You're Turbosmart. You sell turbochargers? The amount of times a day you hear that question. Now, for 25 years, we've said no. The answer to that changed at the beginning of this year. Yes. Okay. So in some regards, it's a matter of filling a void that we know exists because people call us and ask us for turbochargers. So we have a degree, we have a market. And ultimately, the other thing you need to think about is every other product that we sell goes on a turbocharged vehicle, yet we don't sell the turbocharger. So with any business, there's two major things you need to think about. Product is important, but customers are more important. You don't have a business without customers. You can have a business without a great product if you've got good customers. I'm not saying it's not a great product, but I'm saying you got to have both sides of the equation there. And in my experience, customers are harder to find than good products. And so there's plenty of good products in the market that flop because they don't have a customer base. We already have a great customer base. We have good relationships with the workshops. We have good relationships with our customers. We build a quality product across the board. Turbochargers introduced another quality product for us that we're selling to those customers. And so you kind of already had half the recipe with the customer base, the relationships that we have, people trust us. And so bringing in the product is a lot less bold when you know you've already got the customers. And so that was a lot of the decision-making process. The other thing is, Nick, our company owner, it's been a vision of his to sell turbochargers for 25 years. The timing was just right now. This is not the first time we've attempted to do this, by the way.
Okay. Obviously, I'm not trying to downplay the complexity and the engineering that goes into every other product that Turbosmart produce. But I mean, knowing turbochargers as well as I do, this steps things up to like 20 on the dial. There's a lot going on there. As I understand it, you've partnered with HPT to manufacture these turbochargers. So this isn't something you're doing in-house?
Yeah, correct. So we have been working with Harry. So we released those, I guess, the end of last year. We've been working with Harry for probably 2 years now on the design front. Obviously, background is Harry had a very successful turbocharger company that he sold 5 or 6 years ago. He had a non-compete after selling his company. Once that non-compete period was over, we were able to contract him to help us with some design. Manufacturing. He's obviously got a lot of contacts, so it worked well for us. The thing that is a massive limitation in manufacturing turbochargers is A, number of components, B, the manufacturing requirements to do it. If you think about the number of castings that you need for a range of turbochargers, and every casting costs, 20 or 30,000 US dollars per casting, per mold, I should say. And then, you might have, I don't know, for one size turbo, you've got 3 ARs. By the time you've got a range of 15 or 20 turbine housings, that's just the turbine side, you're racking up the bills. It's a lot. So being able to shortcut having his knowledge on selling tens, probably hundreds of thousands of turbochargers in a previous life in the performance space, he was able to shortcut a lot of all right, straight up, we start with a 64 mil housing with a 0.82 rear. That's the most common sort of street in between. You want to run 20 to 45 pounds worth of boost on 2 to 4 litre engines. This is the turbo for you. So having some of that knowledge on the way in, and then obviously saying, okay, what are the design elements that we need to focus on? Well, let's design element wise, you really want to focus on spool time. Bring the weight down, minimize drag on the bearing, increase your aerodynamic efficiencies so that the thing comes up on boost quickly. A lot will fall out after that. We can do some work in the volute, in the casting itself at the top end, but the most important thing is people on street cars want it to spool quickly. So you spend a lot of emphasis on those areas of designing the turbocharger. And it's quite a long lead time as well. Obviously, with the casting, you design a casting, you do a mold. It's 3 months to get a mold, and something has to come out of it. There's a process to that. You get your molds, you machine them. Did they machine well? Yes, they did. No, they didn't. With their voids, it's the manufacturing process up the chop. If you're happy with the mold, then you go ahead and harden it. Okay, that's another couple of months. So the lead time between what you might design in SolidWorks or Ansys or somewhere and having a finished good is easily 12 months. And that's for one housing.
Okay. Interesting insight already. So just to be clear, this isn't a rebranded turbo that someone can purchase from HPT. This is bespoke, and only Turbosmart is selling this product.
Yep, they're not identical. So correct, it's our own branded product, and there's a lot of similarities in some of the components. Now, we use a similar bearing. There's some similarities to sizes. Obviously, we go with what works. And there's Harry's had some great design input, and even as we design more wheels, more castings, you take on board that. You say, okay, that's a fantastic bearing design. We're going to stick with that across the board. Or that turbine wheel works really well. It's got a nice little hub line. It's a bastard to manufacture. It's a shithole to balance because it's got a small hub line, but super efficient. So we want to stick with that. And so, if you to pull the two turbos apart, there's a lot of similarities, but there's also a lot of differences. But most people never see those. There's some differences in the wheel design. There's some differences in obviously we have internally gated stuff. He doesn't have any internally gated stuff. We've got water cooled. He has no water cooled.
And I think it's probably the reason I asked this question, and there's nothing necessarily wrong with just white labeling someone else's product, but I think people want transparency, and is what I'm buying just a rebranded HPT turbocharger? And clearly the answer there is no.
Not with not with Turbosmart branded items. We don't do. I mean, he's got some of the really big stuff that I think he calls it his F5 range, 100 plus millimeter turbos. That's not. We've got nothing in that range.
You're looking at the street car, not the pro mod style, or sort of super high end drag market.
Yeah, that's exactly right. Yeah, that's been our bread and butter and continues to be our bread and butter. I really would like to focus on the street cars. We're obviously working on more designs for future sizes. They'll go down, they'll go up. I don't think at this point in time, I don't see us going into that really large turbo space. Yeah, there's some differences there. Harry's very much focused on. He's right into the Buick scene. I don't know what his fascination is there, but there's got a whole bunch of Buick Grand National replacement turbos and things, which is a weird fetish that he's got.
I do actually remember when I first got interested in drag racing. I followed a lot of the US magazines, and I never really understood. There was always this big thing about these Buick Grand Nationals, but I guess for a US domestic model, I guess they were probably pretty easy to get more power out of and go fast with.
Well, I think, if you look back to when they were released also, when else did you have turbochargers on a domestic, gasoline engine in the States? It's just, you get an Eagle Talon or a Buick as turbocharged. They were the things, so you've got a sport compact there and you've got a domestic. So that's probably where it stems from.
Again, with a complicated product like a turbocharger, obviously you kind of able to leverage all of this previous knowledge that Harry's got. I'm just interested, did everything kind of just work out exactly like you'd expected when these things hit the ground and actually started, doing some proper testing, or were there any sort of challenges or problems that you faced?
I mean, you expect challenges. So I don't know that there was challenges that we didn't expect to face. Definitely, it's a learning curve. It's still a learning curve. Probably for me personally, and I guess us here in Australia, one of the biggest, not challenges, but the things we've come across is just the pure volume of components that you need to keep in stock. You think, realistically, I think we've got 7 or 8 sizes of turbocharger by the time you've got a 5862, a 62, 62, 64, 60, whatever. But each of those sizes will have 2 or 3 or 4 in some cases flanges on the turbine housing. So T4, T3, V-band, T4 divided. Then you'll have multiple ARs. So for one size of turbo, you can have 7 or 8, 9 different sort of combinations.
Are you offering these in reverse rotation, or am I mistaken?
Yeah, and then you layer on reverse rotation, double that number, but that's also doubling the number of housings, turbine housings. You can't share those; they're a completely different housing. Then you throw on water cooled, so we're water cooled and oil cooled, so that the center core is different. So you times that by 3, and all of a sudden, for the 8 sizes of turbos, you've got 250 part numbers and $7 million worth of inventory because it just adds up. And you very quickly see, and when we went into this project thinking we're Turbosmart, we want to produce a premium product, and you buy a turbocharger from us, it comes with everything you need. So it comes with the well flange, and it comes with the V-band clamp, and it comes with the gaskets, and it's all assembled. If you buy one of our internally wastegated setups, it's got the wastegate and the bracket, everything's bolted up, and you bolt the thing onto your car. And we sit them on the shelf complete. But you realize, oh man, everyone else does this super core turbine housing arrangement, and you think, yeah, we want to provide a finished product to the customer. And you realize, oh no, I see why they do this super core thing. You effectively got 8 products and 50 different housings that make 200 finished turbos. It makes so much sense. I can sit on a couple of hundred super cores and then turbine housings, which are the single component that they can put them together. And so that's been the learning curve from a procurement and production perspective, from an actual product perspective, the things have been performing really well. No major red flags in the real world with performance. Along the way through the testing, some things that we found, like the number of turbine blades that we expected to work on some of our smaller turbos, just a turd. You think, oh, gee, that's strange. We didn't expect that. So you go down in sizes. The geometry needs to change relatively significantly to maintain reasonable levels of performance, even against the competition. And so some of the work that we've done in design and cutting wheels and things, you say, oh, wow, didn't expect that. Try something else.
Try something else. Yeah. Okay. Back to the drawing board. Interested, do you provide data like compressor maps for these?
Yep. So compressor maps we do. I'm just putting the last couple of compressor maps together now. That's a significant amount of work. Getting compressor maps, and there's two ways of doing it. You can model it, and you can do real world testing. You've got to do both, and then validate the two against each other. And so there's a reason that many aftermarket turbo manufacturers don't provide compressor maps, because it's a huge project. But yeah, so we have them available for everything up to the, I think, 76, 75, and so the 78, 80s probably be done the next week or two. But they're all available on the website.
Sure. And can you give us some insight? I mean, how's the gamble worked out? Has the demand met expectation, exceeded it, still building up? Where are we at?
It's still building. Demand has been really good. I think with turbos for us, when we first released them, we couldn't keep them in stock. It was excellent. I mean, I think it showed a lot of the confidence that our customers have in us to produce a good product for the market.
Yeah, I think you've got a reputation and there's a level of trust in the market for anything that holds that Turbosmart brand.
Yeah, that's it. And of course, the first batch you get are probably a relatively small batch in production perspective, and so you think, oh, I got the first 100 turbos coming in, and like they're gone the same day they came in. You're like, holy cow, we need to get on top of this. But what you forget is the lead time is 3 to 6 months between when you place an order when you get something, and so that steering that ship can be tricky, because you got people screaming at you for turbos for 3 months because they're coming in slowly, and then the volumes start coming through and you start swimming in the things. And we projected that with all of our sort of financial modeling, and 6 months in, you're really sitting in that hole of, all right, you got a lot of turbos coming in stock. You need them because you do need to have all those housing combinations available. And that's one of the things that we found. So many conversations early on, which were, oh, I want that 62 in a 0.96. Do you have a 0.96 housing? No, we don't. Oh, I need the 0.82 in a T4 or a T4 divided.
They always want what you don't have, right?
It feels that way. Yeah, it feels that way. So it's a bit like Swiss cheese. There's all these holes in the market. With enough pieces of Swiss cheese, you can cover all the holes. But while you've still got plenty of holes visible, it's like, it feels like you can't sell anything because you don't have everything. We're really only just getting on top of that now. Even now, I'm still waiting on 2 or 3 different sizes of turbine housing to really complete the range of products that we released 6 months ago.
Yeah, I can only imagine how difficult that would be, trying to assess and guess what the demand's going to be and what people are going to want. And I don't know if it's possible to get that 100% right. At the same time, I reckon if we had this conversation in another 12 or 18 months' time, this would all be forgotten. You've got your systems in place. You're going to know what the demand is, and you've got your lead times dialed in so that the customers aren't waiting. There's nothing worse than releasing a new product to market. Everyone gets hyped up and excited about it, and then they can't buy the damn thing.
It's so frustrating. And one of the big differences with most of the other products that we sell is we machine everything in-house. For a wastegate, 99% of everything in that thing is done in-house, with the exception of the casting. Okay, you got a stainless steel casting. No one in Australia is casting those things. Everyone knows that. There's a lot more cast components in a turbo, so you're doing a lot less machining in-house, and so you're a lot less in control of the speed at which you can make changes or get products to market or do a different machine plan or whatever it might be, different machine path onto a component to make a different size. Whereas we have a lot more control over that with wastegates, and there's just a lot less components in a wastegate. Actually, not true. There's a lot of components in a wastegate, but most of them we share across a lot of the different gates, different sizes. And so it's a bit different with turbos, and they're sort of new to us. So we don't have a backlog of, we know that a bearing is going to take 9 months to come in after we order it. And the supplier might have said, yeah, that's a 4-month lead time. But in reality, when you start ordering thousands at a time, they're like, oh.
Except now it's not.
Yeah, that's exactly right. You're like, hang on. Or casting's investment cast stainless is a bit of a tricky process. And so you go to a supplier, yeah, I can do that. And you wait 3 months to get the thing back, and you can't use it because it doesn't machine up properly, or it's warped, or they haven't let it cool enough, or it's got impurities in it, or whatever it might be. And you think, oh man, how do you get around this? And so manufacturing things. You get on top of that. Stock handles a lot of that over time. Once you've got the first run of stock, you're okay, because it's like, okay, something gets blown out by 4 weeks, it's not going to be a big deal. But on the first run, that's 4 weeks worth of sales I'm never going to get.
Yeah, it's definitely problematic. All right, Matt, I'd love to talk about some more of the product line, but we've just blown past 2 hours, and I do want to respect your time. So I think we're going to probably have to park that and maybe keep the other products for a conversation on another day, which is also fine. I think there's been some absolute nuggets of gold in the information you've given us so far, so we do appreciate you going into so much depth. I guess before we move into our wrap-up questions, and the sort of first one is going to be kind of the same. So my question here is there anything else that's on Turbosmart's development list, maybe that you're allowed to share with us? I mean, I know that for the last 30,000 years, Turbosmart seemed to have won the Innovation Award at SEMA pretty reliably, and I guess that always requires you to come up with a new product in time for a SEMA launch. Any tips, secrets you can share? Get us ahead of the curve?
I don't think there's any secrets to share. It's probably no secret what we do. We do turbos, wastegates, blow-off valves, fuel pressure regs. There'll be more innovation. There's more iteration in that space. But to be truthful, the turbocharger project is huge. There'll be years of development and new products coming out along that space. So that's likely where you'll see the most development time spent.
It's pretty exciting to me. Sort of turbochargers are my bread and butter. And like I look back at the technology we had available back when I was running my old drag car, and it had an HKS T51R SPL ball bearing turbo, and like by modern standards that is an archaic pile of crap. And just what people are doing, the power they're making with the response that they're achieving on modern turbochargers that are, essentially half the size of what I had, it is pretty exciting, and I'm here for it.
Yeah, no, it's definitely exciting. It's an interesting space to be in. The amount of computer-aided design that goes into a modern turbocharger is outrageous. Just the software they use to design it, you don't even own it, you rent it, and it's thousands of dollars a month to rent the software because you don't have the server space to run it. So it's super interesting stuff, and you're kind of on the bleeding edge because OEMs, they've got a different purpose. They're not looking for performance. They want things to stay together for a bazillion miles under all conditions, and then they've got to cast everything. And so, what we're doing with some of this design on the aero side of things is it really is kind of cutting edge technology. We just didn't have the computing power to do for even 5 years ago. So that's pretty exciting.
All right, so the 3 questions we ask all of our guests to wrap up. The first, and again, there's a little maybe sort of overlap with that last question. What's next and in the future for you and Turbosmart?
Well, next with Turbosmart's turbochargers, and me, I'm happy with my seat here. I'm happy to be involved, and there's stacks and stacks of opportunity. So I think me personally, I'll still be here. Yeah, if they have me.
Yeah, cool. Next question, is there any advice you'd give to a younger version of yourself to help reach where you are in your career today faster?
I don't know that I would have advice to reach where I am faster, but I would say take advantage of the opportunities when they come up, and they do come up. Say yes to things, do the travel, go to the places, and be willing to learn. You don't know everything. Here's a hot tip. You don't know everything right now. Don't let that get in the way. You won't know everything. You're going to be 25 years in where I'm at now, and I realize I don't know everything. In fact, I know a hell of a lot less now than I think I did 20 years ago. Well, at least that's how I see it. So there's always something to learn from somebody, and just keep an open mind. Ask a lot of questions, build your knowledge, have strong convictions loosely held.
Fair. I mean, again, this is something that I talk about pretty regularly on the podcast, but that particular point, the Dunning-Kruger effect is real. You move into a new field, you get started, in 5 minutes you think you're the best in the world. And the reality is that the true professionals have been in that industry for 10 plus years. The more you learn, the more you start questioning things, and the more you realize you don't know everything. So, yeah, tempt your your perceived knowledge and be humble.
Yeah, what do they say? God gave you 2 ears and 1 mouth for a reason. Use it in proportion.
That's fair. It's a good saying, actually. I like that. I might repurpose that. Last question, Matt. If people want to follow you, see what you're up to, see what Turbosmart are up to, how they're best to do so?
Follow on along social, so Turbosmart HQ, on the Instagram, Facebook, YouTube. That's where we're at. Best place to get me.
Perfect. And as always, we'll put links to those social media accounts in the show notes to make it easy for people to find. Always a pleasure chatting with you, Matt, and we do appreciate your time given this one has gone long, so great to get some insight into two very different but very interesting areas of your career.
Yeah, thanks for having me. It's been a pleasure. Sorry I took so much of your time, but it was interesting. Do it again.
Absolutely. No need to apologise. It was me asking the questions.
All good.
All right. Thanks, Matt.
All right.
If you enjoyed this episode of Tuned In with Matt Wright, we'd love it if you could drop a review on your chosen podcasting platform. These reviews really help us to grow our audience, and that in turn helps us to continue to get more high quality guests. To say thanks, each week we'll be picking a random reviewer and sending them out an HPA t-shirt free of charge anywhere in the world. This is also a great place to ask any questions you might have too, and I'll do my best to answer them if your review gets picked. So this week, a big shout out to Lightning Leo from Australia, who has said, "Such a great podcast. I always learn something new and I love the long form format interviews." Well, glad that you're enjoying the podcast. And if you get in touch with your t-shirt size and shipping details, we'll get a fresh tee shipped straight out to you. All right, that concludes our interview. And before we sign off, I just wanted to mention for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis and race driver education. Now remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.